Hello everyone, welcome back to NEET Physics Crash Course 2026. Dear students, in the earlier 5 lectures, we have completed the basic maths portion. In this lecture, that is lecture 6, we are going to deal with vector algebra. So as you all know, in physics, that is in 11th, 12th high school physics, we have to deal with two kinds of quantities. The first one is scalar and the second is vector. So one by one, let us have a look at the features of scalar quantities and vector quantities. So first I am writing about scalar. So any quantity which has only magnitude, there is no sense of direction, isn't it? Is known as scalar quantities. So this is the very basic definition of scalar quantity. For example, the mass of this pen is, let us suppose it is 10 grams and there is no sense of direction. Now if I put or if I associate some direction with it, for example 10 gram towards east, 10 gram towards west, so it is meaningless and it will become funny, isn't it? So there is no sense of direction. If I ask you the length of this marker, again it has no sense of direction. So there are certain quantities, for example mass, length, time, energy, etc. So these are certain quantities which do not require direction to be defined completely. They have only magnitude, isn't it? So these are scalar quantities. But dear students, what happens? There are certain quantities which have direction, but they don't follow laws of vector addition and they are treated as scalars. So what is the second point is addition of scalar quantities. Addition of scalars are done by using simple rule of algebra. Simple rule of algebra, that is 2 plus 3 is equal to 5, 3 minus 2 is equal to 1. These are the simple rules of algebra which you have studied since class 1, isn't it? So what I am saying, there are certain quantities, for example pressure, electric current. Electric current has direction, that it always flows from high potential to low potential. Pressure is having direction, that is it always acts along the outward drawn normal to the surface. Pressure inside any closed container is always act like this, that is its direction is always along outward drawn normal, isn't it, perpendicular to the surface. They have direction, but actually when you add pressure, their addition follows the simple rule of algebra. They don't follow laws of vector addition. So these quantities, though they have direction, but they are treated as scalars. Why? Because they just being added by using simple rule of algebra, isn't it? Now the fourth point is very important. Scalar may be represented as dot product of two vectors, isn't it? What is dot product? Definitely in this lecture, in the upcoming minutes, we are going to deal with it. So for example, what is a scalar quantity? This is dot product of two vectors. For example work done. So work is dot product of force vector and displacement vector. So this is given by Fs cos theta, where F is the magnitude of this force vector, S is the magnitude of this displacement vector, and in this way we write vector, put arrow over the symbol, and theta is the angle between the direction of force and displacement. So work done is a dot product of force and displacement. Similarly, in class 12th, you have studied about, that is electric flux and magnetic flux. Now if you talk about this electric flux phi E, so it will be given by, it is given by E dot A, where A is the area vector and E is the electric field. So this may be written as EA cos theta. So electric flux is also a scalar quantity. Similarly, if you talk about magnetic flux, replace this electric flux with magnetic flux and the area will remain as it is. So this will be BA cos theta. So these are the features associated with scalar. Now the second quantity is, that is vector quantity. So what are the features of vectors? Let us have a look. Vector. So what are the condition for any quantity to be vector. So the condition number one, the quantity must have magnitude definitely, plus there must be a sense of direction. It means that without putting direction, the definition is incomplete, isn't it? If I say the force is acting, for example, let us say about force, if I say the force acting on this particle, on this pen, is 100 Newton. So, dear student, this information is incomplete if you don't add direction to it, isn't it? Because the force 100 Newton may be act in any ways. It may be act like this, it may act like this, it may act like this, isn't it? And if you change the direction of force, the effect will get changed. So, direction is the, you can say direction is foremost requirement if you are going to define the vector quantities, isn't it? So this vector must have magnitude, direction, as well as the quantity must to follow laws of vector addition. What are the laws of vector addition? We are going to learn, isn't it? So laws of vector addition. So these are the features. Now what are the example? Example is velocity, displacement, acceleration, force, etc. Second, third is vector quantities are the cross product of two vectors. There are two kinds of products. The first one is dot product, that is being scalar quantity. The second one is cross product of, so what is cross product? So there are certain quantities like torque, angular momentum. These are the cross product of two vector quantities. So scalar was dot product and this is cross product. Example, if you say torque, so this is the cross product of position vector and force vector. Position vector of point of application of force, the point at which the force is being applied. And magnitude wise, it can be written as tau is equal to Rf sine theta. One more example is of velocity, which is given by angular velocity. So this omega is representing the angular velocity. So V is equal to omega cross R. Now, next slide. Which of the following is not a vector quantity? Speed is not a vector. Speed is a scalar, whereas torque, displacement, and velocity are vector quantities. Earlier, there was AIPMT before the NEET exam, isn't it? Now, representation of vector. So, dear students, represent this vector is represented by putting arrow. For example, if I talk about velocity is equal to 25 meter per second towards east, so velocity is written as, put the symbol of velocity and put some arrow, put an arrow over this symbol, and this will represent velocity is equal to 25 meter per second towards east. Now this is represented in a form of sentence. How can you represent it diagrammatically? So in diagram, so we use arrow to represent it. For example, so there is a way of representation of scalar quantities. This is very important. Suppose this direction is east. Just remind the map of India. This is east, west, north, south. Now you have to represent 25 meter per second towards east. So the very first step is draw a line with an arrow, isn't it? Now this is known as tail, that is a starting point of the vector. This is known as head, that is terminal point, isn't it? Arrow should point towards the direction along which the vector is. So here the vector 25 meter per second is towards east. So put arrow towards east. The first step is completed. Second step, what about the length of this line? So remember, the length of this line, represents the magnitude of the vector, isn't it? So I am writing here L is equal to length of the line is equivalent to magnitude of vector. And what is the magnitude of this vector? This is 25 meter per second. Now suppose if I draw this line equal to 5 centimeter, then what happens here, student? This 5 centimeter is actually representing 25 meter per second. So 1 centimeter will represent 5 meter per second. So this is known as scale factor. So we represent vector quantities by using scale factor. That is 1 centimeter is equivalent to 5 meter per second. Now if you are asked to represent 10 meter per second towards east, if you are asked to represent 10 meter per second towards east, so how can you represent? First of all, the arrow is towards east. So this is east. This is east. The arrow must be towards east. Second, this length must be 2 centimeter. Why? Because 1 centimeter is equivalent to 5 meter per second. So 2 centimeter is equivalent to 10 meter per second towards east. So in this way, we represent any vector quantity, isn't it? Next, polar vector and axial vectors. So dear student, as far as NEET physics is concerned, you have to know just one thing, that polar vector, if I talk about polar vector, it is associated with the translational, or you can say linear quantities. Translational or linear quantities like velocities, displacement, force, acceleration. So these quantities have some initial point, isn't it, and directed towards a particular point. So these are quantities known as polar vectors: velocity, displacement, acceleration, force, etc. Second is axial vectors. So axial vectors, as its name suggests, axial, it is always along the axis, always along the axis of rotation. So these are associated with rotational quantities. Associated with polar vectors are vectors of rotational quantities. And what are the rotational quantities? That is torque, angular velocities, angular momentum. So these are the like torque, angular velocity, angular momentum, etc. Angular momentum, isn't it? Now, how can you find its direction? Simply by using right hand thumb rule, isn't it? So let us have an example. How can you find the direction? So, for example, if I draw, let us suppose if I draw a like this is rotating in this thing. These are the blades of the fan or turbine. Now, so definitely if it is rotating like this, so it must have axis like this one, and this is axis. This fan is representing the axis, and this is the sense of rotation of the blades of this turbine. So what happens if it is rotating like this one? So the direction of angular velocity is along this axis. It means that the angular velocity may have two directions. I mean, there are possibilities, two possibilities. Since the direction of angular velocity is along the axis, so it may be, its direction may be towards the board, into the board, or away from the board. So out of the two choices, we use right hand thumb rule to find the actual direction. So the step is curl the fingers of the right hand in the sense of the rotation of the blades, isn't it? So I am curling it like this one. So this stretched thumb will give the direction of the angular velocity. So here, this stretched thumb will give the direction of angular velocity. So this is the direction of angular velocity that is perpendicular to the board and perpendicular to this board and coming towards you, isn't it? So in this way, you can find the direction of these axial vectors. And suppose if the blade was rotating like this one, so then the direction will be into the board. So these are polar vectors and axial vectors. Now the second next slide is coplanar vectors. So any vectors which lie on the same plane, suppose these are vectors lie on the plane of this board, so these are coplanar vectors, isn't it? These are coplanar vectors because these are all lie on the same plane, that is the plane of the board. Now as far as collinear vectors are concerned, so these are parallel, these are parallel. So suppose this is vector A, vector B, and this is vector C. If you observe the line of actions of this vector, the line of action, these are parallel to each other, so that's why they are known as collinear vectors, isn't it? So here A is parallel to B, so A is actually parallel to B. Why? Because both are pointing along the same direction. But when we talk about C, so A is anti-parallel to C because direction of A and C are opposite to each other. But their line of action are along the, I mean, same line, isn't it? So their line of action are parallel to each other. So that's why they are known as collinear vectors. So the next is null vector. This is very important, dear students. Null vector. So when null vector is obtained, the very first point is when the two vectors of equal magnitude act along the opposite direction, then you can have a null vector. For example, suppose there is an object, and if I pull this object by force, F1 is equal to 50 Newton, and I apply the second force on the second side, opposite side, and pull this object by the same force, that is 50 Newton. So these F1 and F2 are actually having magnitude same, but their directions are opposite to each other. So what happens? The net force acting on this object will be 0. Why? Because it will move nowhere, isn't it? If there is only one force acting on the object 50 Newton, then the object will move towards left. Otherwise, है ना? And what happens if there is a single force acting on the object 50 Newton towards right, then definitely object will move towards right. But now what happens? F1 has tendency to pull it left, F2 has tendency to pull it towards right, and their tendencies are equal to each other. Are you getting that? Their tendencies are equal to each other. Why? Because both are having magnitude 50, that is 50 Newton. So object will go nowhere. So net force acting on the object will be 50 minus 50 because these two forces opposing each other. So this will be 0. If I write its magnitude, then it will be 0. But if I write it in vector form, that is F net is equal to F1 vector plus F2 vector. So this will be actually 0 vector. Are you getting? This will be actually 0 vector, and this is known as null vector. So from where the null vector is obtained, it is nothing but addition of two vectors which are having same magnitude, but their sense of direction is exactly opposite to each other. So null vector is obtained when two vectors of equal magnitude but having opposite direction are added. So null vector is obtained, isn't it? So it is represented by 0, isn't it? Now since it is having magnitude 0, so you cannot attach any direction to that 0, isn't it? In maths we say 0, but actually what is the meaning of 0? 0 is nothing. So if you say nothing along particular direction, it makes no sense. Therefore we say that this 0 vector has undefined direction, dear student. This is very important. This 0 vector has undefined direction. And the last most important thing is 0 vector is not equal to 0. This is conceptual point. Why? Because this 0, when you get this 0, this 0 is representing the magnitude, or you can say difference of two scalars. Difference of two scalars. because scalar doesn't have direction, isn't it? Suppose you have 2 liter water in a container, and if you take out that 2 liter water from the container, so the result will be 2 liter was earlier, you take out 2 liters, so 2 liter minus 2 liter is 0 liter or 0. So it is 0 actually, the difference of two scalars. But this 0 is actually vector, that is difference of two vectors. Are you getting now? So this is the logic behind it. So 0 vector is not equal to 0. Next is vector shift. This is very important. This concept is being used in solving numerical. Suppose there are vectors. Suppose there is a vector like this one, vector A, and if I shift it parallelly, suppose I copy it and here paste it. Now this second vector is parallel to this vector. So if I shift it anywhere, isn't it, anywhere, so it will make no change to this vector, isn't it? These two vectors are representing the same thing. Why? Because both have same direction and the length of this both line is same. So this is also a vector. Are you getting? So vector, so the key point is vector when shifted parallelly, vector, any vector when shifted parallel makes no change, or you can say remains unchanged, isn't it? Remains unchanged. Remains unchanged. Any vector, if you shift it parallelly, it will remain unchanged. This is the logic. Angle between two vectors. Now, if I talk about angle, listen dear students, for taking angle, since we are learning from the very basic, so this angle is known as, this is angle between two vectors represented by theta. Observe carefully, this theta is always less than or equal to 180 degree, because some students may ask that sir, this angle may also equal to theta, angle between the vectors, but this will become greater than 180 degrees. So out of the two values we choose the lesser one, isn't it? So how can you take angle theta? Just first suppose this is a vector and b vector. So first, the very first step is put the tails of the two vector so that they coincide, isn't it? Tails of the two vector must be at the same point. Now there may be different cases. Suppose now like this one, isn't it? So how can you find the angle between the two? This will not be the angle because one is having head at this point and the second is having tail at this point. So what we do, we just shift this vector just above point, isn't it? We shift this vector parallelly such that the tails of the both the vectors coincide. So this will be, so this angle will be theta, that is angle between the two vectors. So this is how we represent the vector. Suppose vector is like this one, like this one. Now how can you find the angle between the two vectors? So either you can shift it, or the second method you can adopt is just extend the direction of the two vectors. For example, the direction of the second vector, let us name it, this is, let us suppose this is a vector and this is b vector. So what is the direction of second vector, dear students? Suppose if I talk about vector b, so what is its direction? So this is the direction of vector b and this is the direction of vector a. So this angle is actually theta. So in the first step, what we have done, in the earlier example, what we have done, we just shifted this vector here. But in this example, I am going to explain you. If you can't shift it, just extend the direction, isn't it? The direction of B is like this one, so extend to it in this way. So this angle will be equal to theta. In this way, you can have directions of the vector. Now, the second is, suppose the two vectors are like this one, the first vector and the second vector, both are parallel to each other, and this is the second case. So here suppose that this is first vector, this is second vector, this is a and this is b. So angle between a and b is given by 0 degree, isn't it? Because both vectors are A is parallel to B. Now what about this vector? Suppose this is vector C and this is vector D. Now here the angle is, so here in this case, in the second case, the angle is given by 180 degree. So this angle in this case, the angle is given by 180 degree. Theta is equal to 180 degree because the direction of both the vectors are opposite to each other. How can you say that this is opposite to each other? Just shift it. If you can shift it, just shift it. So this will be like this one, like this one. Now observe carefully, both are opposite to each other. So this angle will be equal to, this angle will be equal to 180 degree. So these are the different cases of angle between the two vectors. Next is multiplication of a vector by any constant. Suppose there is a vector A and if I write B is equal to K times A vector, where K is having positive value. Let us say, for example, if I represent a vector force. Now let us suppose the force is here equal to, this force is equal to 2 Newton, and definitely if I write along east, this is east, this is, so F vector is like this one. Now if I represent another vector F dash, which is like this 3 into F vector. So what changes does it make in this vector? So the very first thing you have to keep in mind that this 3 is having numerical value. So it will change the magnitude of the vector, but it doesn't change the direction of the vector. So the direction of vector F dash vector and F vector will remain same. So magnitude will be, now magnitude of this vector will be, this is 3 into 2 Newton along east, isn't it? So this will become 3 into 2 Newton is 6 Newton along east. So observe carefully, along east part will remain same as it is. So the second vector must point towards east, and length of this line is, suppose if this line is 1 centimeter, so this line will be equal to 3 centimeter. Why? Because if 1 centimeter is representing 2 Newton, then by using the scale factor concept, we can say 3 centimeter will represent 6 Newton. So both are having the same direction, but their length is different because they have different magnitude. So whenever you multiply any positive constant to any vector, it will change its magnitude only. It will not change its direction. So this is the first concept. Second concept, dear students, what happens if I say in the using the same example, if I say suppose f vector, suppose f vector is equal to, this is what is 2 Newton. This is 2 Newton along east. So this is like this one. This is f vector 2 Newton along east. This direction is definitely, this is east. Remind this is west India map, this is north, and this is south. Now if I say minus f dash, now remember the very important concept is this minus sign is related to or is indicating the reversal of direction. Always remember, magnitude of vector can never be negative. So this concept will help you to understand this. Magnitude of vector will never be negative. Will never negative. So you cannot add this minus to this magnitude. Minus 2 Newton. No. Magnitude is always positive whenever you are going to represent any vector quantity. So minus sign is not associated with magnitude. Since vector has two things, if minus sign is not associated with its magnitude, it means that minus sign is associated with direction. That's all. So what happens now? This minus f dash vector is actually 2 Newton along west. Why? Because if you take positive along east, then if you put minus sign here, then it means that the direction gets reversed, isn't it? So this is minus f vector is 2 Newton along west, and that will be represented by this one. Both are having the same length because magnitude is same, that is 2 Newton, but direction is exactly opposite to each other. Now, if I say 10 meter per second towards north, velocity is 10 meter per second towards north, isn't it? Now, if I put minus sign here, minus 10 meter per second, it means that that minus is representing the direction towards south. If I take positive direction towards upward, then if I put negative sign, then negative direction will be towards downward. So in vector, what happens now? Whenever you put minus sign, it just shows the reversal of direction. This is very important. This is showing the negative of vector means reversal of direction. Direction gets reversed, isn't it? This is the quantity. Now suppose if I say there is f vector and there is f dash vector. F dash vector is minus 4 times f vector. Now again, if f vector is 2 Newton, then it will be again the same thing. The magnitude will be 4 times the earlier vector. That is earlier vector, that is f vector is 2 Newton. So the magnitude of f dash vector will be 2 into 4, 8 Newton. But here it is minus sign, so it is changing the direction. So the very core concept is, if you multiply positive constant with a vector, it doesn't change its direction, it only changes its magnitude. If you apply minus sign, then it will change both the direction as well as magnitude, and it reverses the direction, isn't it? Now what happens if you represent it? So this will be f vector and this is f dash vector. This is f vector and this is f dash vector, isn't it? So its length is 4 times this length. Why? Because it has the magnitude 4 times. And as far as negative sign is concerned, f is pointing towards east, then f dash is pointing towards west, opposite direction. So that's all for this. Next is unit vector. It is very important. If I write velocity of any object, velocity represented by v, this is 10 meter per second along west, if I write this way, isn't it? So this can be written as, dear students, 10 meter per second into 1 along west. Now there are two things, isn't it? To define the velocity, there are two things. This actually numerical value along with unit. So this is representing the magnitude of velocity. This is representing the magnitude of velocity. And magnitude is represented by simply v, or put mod sign or keep this v vector under this mod sign. These both are representing the magnitude of velocity, that is 10 meter per second. Now if you observe this one along west is giving the sense of direction to the velocity. Sense of direction, and the direction, its sense of direction. So what direction is I have put here? West. That is the direction of this velocity. So velocity vector is being represented by two things. The first one is v vector, and the second is, this is one along west. This is actually giving the direction. So what happens now? This magnitude is being represented, so this can be written as v vector, that is magnitude, in this way. And this one along west, if you observe particularly this, this is one along west. So what happens now? This is actually having magnitude equal to 1. If I talk about particular, why magnitude equal to 1? That is unity. Because we have written 1 along west. 1 along west. So this is having direction along west, and this direction is towards the vector which we are going to represent. And one is having one is its magnitude, that is it is having magnitude equal to 1, that is unity. So that's why this is known as, since this has magnitude, since this has direction, and its magnitude is 1, so that's why this is known as unit vector. Unit vector represented by, put symbol v and put cap over the v. So this is known as v cap. It is read as v cap. So this will be v multiplied by V cap. So from here we get V cap is equal to V vector by magnitude of V vector. So any vector, if you wish to find unit vector A cap, so it will given by A vector by magnitude of the same vector, isn't it? So what are the features of this unit vector if you understand it? So carefully, what are the features of unit vector? I'm going to write the features. So the very first feature is, dear students, the very first feature is magnitude of unit vector is 1. So magnitude is equal to 1. What about the direction, or what is the use of unit vector? Actually, it is giving direction to that vector. So it uses to gives direction. So simply I am writing gives direction. The third one is, it is having unit or dimension like this? No, because the unit is associated with magnitude, so it will go through the magnitude. We are left only with 1. So it is just a numerical value, it is just a number. It is unitless and dimensionless. It is unitless and dimensionless. So this is the third very important feature, isn't it? And it is given by, as we have written, A cap is equal to A vector by magnitude of A vector. And the most important point is, now we have in Cartesian coordinate system, we have three axes: x-axis, y-axis and z-axis. So unit vector along positive x-axis, if I write unit vector along positive x-axis is equal to I cap. Similarly, unit vector along, one more thing, if I write unit vector along positive x-axis is I cap, isn't it? Now, if I write unit vector along negative x-axis, so what happens if this is positive x-axis? Then just towards the opposite direction, this is negative x-axis. So the direction of positive x-axis and negative x-axis are exactly opposite to each other, isn't it? So what happens? I put minus sign here, because just we have learned that if I put minus sign, it just reverses the direction. If I cap is positive along positive x-axis, then minus I cap will be along negative x-axis. Similarly, unit vector along positive y-axis plus y-axis is j cap. So definitely minus y-axis along minus y-axis will be minus j cap. Similarly, unit vector along positive z-axis is k cap, and unit vector along negative z-axis is minus k cap. So in this way, now how we can use it to define any vectors, further we are going to see it. Next is position vector and displacement vector. So dear students, now we will use the concept of I cap, j cap and these all things, isn't it? Suppose let us start with having 2D system, that is we have x coordinate, x-axis and y-axis, and if I take a point here, this is a point representing, so this is a particle is kept at point P having coordinate x and y. So as we have learned in coordinate system in basic maths, isn't it, that concept has been going to use here. So what happens if I join this? So actually this value is, this is y and this is x. So what happens to locate particle P? We have to move x distance towards x-axis, this is x-axis definitely, and we have to move y distance towards y-axis. So this is how we represent the particle. Now what happens now? This is origin. Now join this two line, join this one. Now if I write position vector of particle P, position vector of particle P, or you can say position vector of particle which is at point P, it is given by OP vector represented by R vector. This is very important, dear friends. This is very important. So always we have to write some features about position vector, but before that it is being represented by O, starting from the O and ends at P. Now one more thing, suppose if you take any particle P dash, isn't it? So its position vector will also be defined by start the line from O and end it at P. So wherever you get, wherever you take the point P, Q, R, no matter. But if you wish to define its position vector, the position vector always starts from the origin and directed towards that point, isn't it? So what happens? The direction of position vector is always from origin to the point. From origin to the point. So this is the first. Now this can also be written as its direction is always, or you can say position vector is directed away from the origin, because here the direction is from O to P, here the direction is from O to P dash. So the direction is like this, that is it is away from the origin. So what happens? I write direction of position vector is always directed away from the origin. Away from the origin, isn't it? So in this way, now the first direction we have completed. Now what about position vector? How we can write this position vector? So since if I write about R vector, so this is R vector, that is OP vector is R vector. So its magnitude of position vector is given by magnitude of position vector, that is magnitude of R. It is given by R mod of R vector, and this mod of R vector is being represented by line OP. So whatever the length of OP, so length of this line OP will represent the magnitude of vector R. So this is equal to OP. Now observe the triangle OPQ. This is Y, this is X. So this OP is given by Pythagoras theorem, root over x square plus y square, isn't it? And if you talk about R vector, this R vector can be written as xi cap plus yj cap. Why? Because to locate this point P, you have moved x distance towards positive x-axis. So that towards positive x-axis is being represented by I cap. Then you move y meter towards positive y-axis, so that positive y-axis is being represented by j cap. So this is xi cap plus yj cap, and its magnitude is given by this value, root over x square plus y square. Now observe carefully, dear student, what is the x? That is coefficient of I cap. What is y? That is coefficient of j cap. So magnitude of vector is being determined by taking the square root and add the squares of the coefficients of I cap, j cap. And if there is third coordinate, that is z axis k cap, then we add that value as well. For example, if I say any vector is being represented by x I cap plus y j cap plus z, that is z k cap, then its magnitude will be given by very simple, root over square of coefficient of I cap plus square of coefficient of j cap plus square of coefficient of k cap. So this is the formula of magnitude. This is very. Now let us understand with some more examples. For example, if I take vector A is equal to 2 I cap plus 3 j cap minus 5 k cap. Now how can you find the magnitude of this vector? Very simple. Put coefficient of I cap is 2 square, coefficient of j cap is 3 square, and as you know, this magnitude can never be negative, isn't it? This minus just showing the direction of this component. So this is actually 5 along negative z axis. Minus is associated with direction and it is not associated with magnitude. Just I have mentioned you, isn't it? Why? Because magnitude is always positive. So here we can write this is 5 square. And if some students say that sir put minus here, if I put minus as well, what happens? this minus square will finally it will become positive. So there is no sense of putting minus here. So this is the magnitude. This is 4 plus 9 plus 25. So this is 25 plus 13. So this is 38, isn't it? So this is the magnitude of this given vector. So in this way you can find, just don't take the minus sign, isn't it? So we have seen position vector. Now we have to see what is displacement vector. Suppose if I write the initial position of a particle is given by r1 vector. So if I write r1 vector is initial position of a particle, initial position. If I take r2 vector is final position. So the displacement vector is given by, displacement is given by final position minus initial position. So displacement is nothing but change in position. Change in position is displacement, and this change in position, anything in physics, if you put change in before that quantity, so it will represent by, or it will be represented by delta, and put the symbol of the quantity. Delta stands for change, r vector is position vector, so this becomes change in position vector. So this will be, and always remember, change means final minus initial. So here it will be r2 vector minus r1 vector. So this is change in position. So in diagram, how can you plot it? Suppose particle is initially at point P1, then particle will get reaches point P2. So the change is given by, suppose this is P1, particle initial position, this is P2. So this is OP1 is the initial position vector, OP2 is the final position vector. So this is the initial point and this is the final point. This is the initial position and this is the final position. So displacement is always given by join the initial position to the final position. So this vector is actually displacement vector. This vector is change in position, or it is given by displacement vector, that is S vector. So what conclusion we have drawn from here is that the displacement vector is given by S. This is nothing but delta r vector, and it is given by r2 vector minus r1 vector, that is change in position vector, isn't it? Now suppose if P1 has the coordinate x1 comma y1, P2 has the coordinate x2 comma y2. What is P2? That is final position of the particle. What is P1? That is initial position of the particle. So delta r will be given by, delta r will be given by, this is x2 I cap plus y2 j cap. So we have written the position vector, that is final position vector of the particle, minus initial position vector x1 I cap plus y1 j cap. So this will be x2 minus x1 I cap plus y2 minus y1 j cap. Now this is the final, or you can say displacement vector. Now if you wish to find its magnitude, so as you know, the formula for magnitude is given by root over coefficient of I cap square, that is x2 minus x1 square, plus this will be y2 minus y1 square. So dear students, we are, though this is a crash course, but we are starting everything from the very basic, and definitely we will reach to the level of NEET and +1 level to it, isn't it? So don't worry, just keep patience and complete the full lecture. Now addition of vector. Before starting addition of vector, well, let me talk about why do we need to add two vectors, isn't it? Now suppose, observe, so before proceeding to addition of vector, the first thing we have to keep in mind that what is a resultant vector. What is resultant vector? Because when we add two vectors, then after addition we get a single vector, and that single vector is known as resultant vector. What is the meaning of resultant vector? So resultant vector is that single vector which produces the same effect as being produced by taken all the vectors together. For example, let us suppose I am giving you example of this. So observe this. Suppose I am applying a force here. It is visible. Now I am applying force here. Let us suppose this is 10 Newton. So it is moving in this axis, isn't it? And if I apply 10 Newton from this side, it is moving like this along this axis. Let us suppose this is x axis, this is y axis, isn't it? Now what happens if I apply the two forces along opposite direction? For example, if I apply this force 10 Newton here, 10 Newton here, both the forces have tendency to move to move this box but in opposite direction. If I apply both the forces together at the same time, then what happens? Observe this. It will go neither this side nor this side. Why? Because this 10 Newton gets cancelled by each other. So what is the resultant of these two forces, that is 10 Newton and 10 Newton? The resultant is 0 Newton. Are you getting what I am saying? The resultant of these two forces 10 Newton, I am applying two forces 10 Newton plus 10 Newton, and this is actually giving 0 Newton or 0 vector, isn't it? No need of putting, this is null vector. So it is 0 vector. Why? Because the two forces cancel each other's effect. The 0 vector is the resultant of these two forces. Why? Because whatever the effect being produced by these two vectors taken at a time, the same effect is being produced by this null vector. It means that both are, in both the cases, this box will not move. Second example you can take, for example, this is 10 Newton, this is 10 Newton. Now if I apply both the forces together, so this will move neither this way nor this way, but it will follow a diagonal path. Let us see. Are you getting? If I apply the single force, it will go this side. If I apply this single force, it will go along x-axis. But if I apply both the forces at the same time, then what happens? Observe carefully. It will follow the diagonal path. So this actually both the forces, what effect is being produced by both the forces, that both forces, if they act at the same time, they move the box along this path, along the diagonal path, isn't it? Now what is the single force of these two forces? It's very simple. If I apply a single force and that single force produces the same effect, that is, it will also move the block along same diagonal direction, then that single force will be called as the resultant of the earlier two forces. For example, if I apply the single force like this one along this direction, it will produce the same effect. The box will move along the same direction as it was moved by the combination of these two forces. So this single force can be termed as the resultant of the earlier two forces. Why? Because that resultant force, that single force producing the same effect. So are you getting now what is resultant vector? The vector which produces, what is single vector that produces the same effect. Single vector that produces the same effect as being produced by the combination of the vectors. So this is, so in this topic addition of vector, we have to find the value of the resultant vector, the direction of the resultant vector and the magnitude of the resultant vector. So how can we do this? So we have different laws. So basically we have to study three laws: parallelogram laws of vector addition, then we have triangle laws of vector addition, then polygon law. So starting from parallelogram law. Now suppose there are two vectors, one is like this one, this is vector A and this is vector B. So what is parallelogram? So what does parallelogram law state? Let us suppose this is vector A and this is vector B. So parallelogram law states that first we have to arrange these two vectors such that their tails must coincide, isn't it? So I draw the two vectors like this one. This is the first vector, this is vector A, and this is vector B. So this is the first step. we have arranged the two vectors, or we have shifted the two vectors in such way that the tails of the two vectors coincide. Now this is vector A, this is vector A, this is vector B. Let the name is like A, B in this way, and this is D. Now what we do, we construct a parallelogram using these two sides or these two vectors. So we construct a parallelogram here. So first of all, we draw a line parallel to this vector A from here, and with the same distance, suppose the length of this is 6.6 centimeters. So here also we draw a parallel line having the same length, that is 6.6 centimeter. So here, and then joining these two points. So here we have a parallelogram. So parallelogram laws say that if you construct a parallelogram using these two vectors, then the diagonal of this parallelogram will give the resultant of this two vector. So what is the diagonal? So here it is the diagonal. This is the diagonal of this parallelogram will give the resultant of this two vector. That is, R vector is the resultant vector. Let us suppose this is C, this is D. So this is parallelogram law, dear students. Since R vector is the resultant vector, that is given by A plus B. It means that whatever the effect is being produced by this vectors A and B, the same effect is being produced by this resultant vector R vector. So now this is resultant vector, this is the parallelogram law. Now understand that this parallelogram may have two diagonals. This is the first diagonal, this is the second diagonal. But we have to take that diagonal whose tail coincides with the tail of the two vectors which you are going to add, isn't it? So this resultant vector starts from the tail of the two vectors and ends at the other end of the diagonal. So this is resultant vector, that is A vector plus B vector. Now if you construct it, let us suppose I drop a perpendicular here, and this is, I extend the vector A in this way. So what happens, dear friends? This angle, the angle between A and B is given by theta. The angle between A and B, this angle, this complete angle is theta. If this angle is theta, so this angle will also be equal to theta. Now one more thing, what happens? If the magnitude of this vector AB is B, so this AB is equal to CD as per the property of parallelogram. So this side CD is equal to B, and this, suppose this is E, this is having 90 degree, that is C is perpendicular to this line AE. So what happens, this B or CD is the hypotenuse of the right angle triangle CED. So the component DE will become, this will be given by B cos theta, and the side CE is given by B sin theta. This is opposite to angle theta. And you can go through the lecture trigonometry, basic trigonometry, that is the part of the basic maths. So this CE is B sin theta, this DE B cos theta. Now in triangle ACE, I am going to derive the magnitude. So what we are finding, magnitude of resultant vector. Magnitude of resultant vector. So magnitude of resultant vector, so R is nothing but given by AC, and this AC is root over AE square plus CE square. AE square plus this is CE square. So it is given by, what is AE? AE is nothing but AD plus DE. What is AD? That is magnitude of vector A, isn't it? So this can be written as, first of all, AE can be written as AD plus DE. AD plus DE whole square plus CE is CE. So this is A plus B cos theta, A plus B cos theta square plus B sin theta square. On solving, you will get A square plus B square plus 2AB cos theta. So this is the formula of magnitude of the resultant vector, isn't it? So this is the formula of resultant vector, dear students. So R square is equal to A square plus B square plus 2AB cos theta. So this is the where A is the magnitude of first vector, B is the magnitude of second vector, theta is the angle between the two vectors. Now we have found out the magnitude of vector A. Now we will find the direction, isn't it? That is very important part. Direction of resultant. So in the second part we are going to find direction of resultant. So its direction is given by, so we have to take some angle here. Suppose I take this as angle alpha. So again in triangle ACE, this tan alpha is given by opposite side, that is CE by AE. So it will be given by tan alpha is equal to CE by AE. Now what is CE? CE is B sin theta. And what is AE? This is AD plus D, that is A plus B cos theta. So this is tan alpha, that is B sin theta by A plus B cos theta. Observe the pattern, that is alpha is the angle made by vector R with A. So we have put A here and B is left. So the sine component of B comes in the numerator and cos component of B comes in the denominator, because sine by cos is tan, isn't it? You can learn in this way. Now if I wish to write tan beta, so here beta is the angle made by resultant vector with the vector B. So here it will be, now A is left, so A sin theta in the numerator plus A cos theta in the denominator, because sine by cos is tan. So in this way you can find a resultant vector magnitude and direction as well. Second is triangle law of vector addition. Triangle law states that, dear students, suppose the two vectors, if they are like this one, that the tail of the second vector is coincides with the head of the first vector. It means that head of the first vector coincides with the tail of the second vector. You can say like this, or you can say it is actually head to tail method. The first vector is approaching the second vector. As you can see, it is approaching the second vector. Or you can also say that they are having sense in this way. So what is the resultant vector? The resultant vector is nothing but start from the tail of the first vector, and or you can say join the tail of the first vector to the head of the last vector. Here last vector is second vector, because we have only two vectors here. So let us suppose if this is vector A and this is vector B. In some literatures you can also say that A and B are in the order anti-clockwise sense. So the closing side of triangle taken in opposite order will be the resultant vector. So here R vector is given by A vector plus B vector, isn't it? This is the angle between vector A and B, isn't it? Because this is the direction of vector A. So again formula will be same. R is equal to the same formula whatever we have derived from the parallelogram law, A square plus B square plus 2AB cos theta, and tan alpha. If this is alpha, then tan alpha is given by, since alpha is made by resultant vector with vector A, so A is here, B sin theta in numerator plus B cos theta in denominator, isn't it? So in this way you can, you must remember just one thing, that in the parallelogram law both the vectors start from the same point, isn't it? But in triangle law, the first vector, I mean this is the starting point of first vector, then second vector starts from the head of the first vector. This is second vector which starts from the head of the first vector, isn't it? And for resultant vector you have to join the tail of the first vector to the head of the second vector. That's all, isn't it? Acha, one more thing, dear students, in the case in a displacement vector, One thing I actually didn't discuss with you, that what is the direction of displacement vector. As you can see from here, the direction of displacement vector is always from initial position to final position. Very basic thing. So now let us come back to the point. So we have completed the triangle of vector addition. Now second is, after triangle law we have polygon law of vector addition. It's very simple, dear friends. Suppose there are number of vectors. This is vector 1, this is vector 2, this is vector 3, vector 4, vector 5, vector 6. In this way, isn't it? Here it is vector 6. Now let us name it as, this is vector A vector, this is B vector, C vector, D vector, E vector, F vector. Now if you are asked to find the resultant vector, so since this is polygon law, there it has many sides. So what you do, the resultant vector is always given by, so this is the key point, remember, join tail of the first vector, join tail of the first vector to the head of the last vector, to the head of the last vector. What is this? So this is nothing but resultant vector, isn't it? So here the vector starts from A, so this is the tail of the first vector and this is the head of the last vector. Join this. So this black line is giving resultant vector, isn't it? So this is the resultant vector. So we can write R vector is equal to, since this is resultant vector, A vector plus B vector plus C vector plus D vector plus E vector plus F vector. Now suppose if I draw the same diagram, I am copying it and I just paste it here. So we have the same diagram like this one, isn't it? Like this one, and I join this way as well. Now if I move, this is A vector, B vector, C vector, this is D vector, E vector, F vector, and let us suppose this is G vector. Now observe the vector R and vector G. What you can see, suppose if I put this R vector in the right hand side, what happens if I shift it the right hand side, that A vector plus B vector plus C plus D plus E plus F. Now this R, when shifted to right side, it will become minus R vector is equal to 0 vector, null vector. So what happens, this minus of R vector, observe carefully, this can be written as A vector plus B vector plus C plus D plus E plus F plus of minus R vector is equal to 0 vector. This minus R vector, as we have learned that minus R vector is having the same magnitude as R vector, but if I put minus sign in any vector quantity, it just indicates the reversal of direction. That is, the vector R, that is R vector and minus R vector, are having the same magnitude but their direction are opposite to each other. The direction of vector R is from this way, suppose from point A to B, but the direction of vector minus R is from B to A. So this is a vector from B to A, and this is nothing but, this is given by vector G, because this vector G is nothing but minus of R vector. Since the length of this both the vectors is AB, so their magnitude is same but their direction is exactly opposite to each other. So this minus R vector can be replaced by G vector, and finally we have A vector plus B vector plus C vector plus D vector plus E plus F plus G vector is equal to 0 vector. So whenever in any polygon, if you start from the starting point, suppose any point you have to start, and after you complete the journey and reaches the same point again, then the effect is 0. So the resultant vector will be represented by null vector. So this is polygon law. But one more important thing in polygon law, that is a special case. Now suppose you have three vectors, observe the pattern. Suppose you have three vectors having same magnitude A, A, and angle between them is same, that is 120 degree, 120 degree, 120 degree. So this vector can be converted into a regular triangle in this way, isn't it? In this way. So angle between, oh, and how it can be converted in this way, it is very simple. Suppose this is vector 1, a1 vector, this is a2 vector, this is a3 vector. So here we have, this is a1 vector, let us suppose this is a1 vector, a2 vector, and this is a3 vector. All vectors are having different directions, but their magnitude is same, that is a. So what happens here, students, if I extend this one, so this is the direction of vector a1 and this is the direction of vector a2, so this angle will be 120 degrees, so this angle will be 60 degrees. Similarly, if I extend this direction, so this is the direction of a2 and this is the direction of a3, so this is also 120 degree and this will be 60 degree, because this two form 180 degree, that is linear pair. And this is the direction of vector a3 and this is the direction of vector a1, so this is again 120 degrees, so this will be 60 degree. So as you can see, all the angles are equal to 60 degrees, so it will become an equilateral triangle, that is regular triangle. And if you start from this point A, after drawing this diagram, you again reaches the same point, so the resultant force will be 0, or resultant vector will be null vector, isn't it? Suppose instead of 3 we have 4 vectors like this one, or we have 5 vectors like this one. This is first vector, this is second vector, second, and similarly all the vectors have, let us suppose this is f1 vector, this is f2 vector, f3 vector, f4 vector, f5 vector, but all are having the same magnitude, f, 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 f. Let us suppose this angle is 72 degree, 72 degree, 72 degree, 72 degree, 72 degree. So 72 5 is a 360 degree. So the angle between any two vectors is given by 72 degree. So again, what is the criteria to form a regular polygon from the given vectors? The very first criteria is the magnitude of all the vectors must be same, and second, the angle between any two vector is same. And so in this case, it is equal to 72 degree, because 72 5 is a 360. So this can be converted into regular polygon, that is pentagon. This is first vector, this is second vector, this is third vector, this is fourth vector, and this is fifth vector, isn't it? So this is regular. So the length of this vector, I mean magnitude of all the vector is same, and that is equal to f. Now if you observe this, if I extend this line, if I extend this line, so this is the direction of first vector. Let us suppose this is f1 vector, this is f2 vector, this is f3 vector, this is f4 vector, and this is f5 vector. So this is the direction of f1 vector and this is the direction of f2 vector. So angle between the two is 72 degree. So if it is 72 degrees, this whole angle becomes equal to 180 degrees. So this angle will be 180 minus 72 is 108 degree. Now if I extend this direction in this way, so this angle, so this angle is again given by the angle between the two vectors 72 degree. Again, this complete angle is 180 degrees, so this will be 180 degree. Now if you extend this, this is again 72, so this angle is 108 degree. If you extend this angle will become 108 degree. If you extend this is 72, so this angle will become 108 degree. So all the angles is given by 108 degree. All the sides of this pentagon is same, so this will become pentagon. And if you add the vectors f1 plus f2, f1 vector plus f2 vectors plus f3 vector plus f4 vector plus f5 vector is a null vector. Why? Because you have started from this point x and finally f5 reaches at the same point, that is the point x, so it will be null vector. there is no gap between the head of the last vector f5 and the tail of the first vector. If there is a little gap also, then again you will have some resultant, but here there is no gap. Actually the head of the last vector coincides with the tail of the first vector, and such that we have null vector as the resultant, isn't it? So in this way any number of vectors can be given, but the condition is if their magnitude are same and the angle between them are same, then their resultant is equal to null vector, isn't it? Now subtraction of vectors. So dear friends, suppose you have to find vector A minus vector B. This is a subtraction. But as you all know that in vector the minus sign is having the significance of reversing the direction. It has nothing to do with the magnitude of the vector. It just changes the direction. So it is nothing but it is you are adding minus of B vector to the A vector. Now suppose here if it is vector A and if it is vector B, I write here this is vector A and this is vector B. So we have to add A with minus of B. So what we do, if it is B, then just if I take this, if I draw a new vector that is having the same length as vector B, that is magnitude of both the vectors is same, but the direction of this second vector is exactly opposite to direction of B vector, then this vector will represent minus of B vector. This vector, why? Because the magnitude of both the vectors, that is length of this both line is same, but the direction of this minus B is exactly opposite to B vector, isn't it? So this is representing minus B, so we have to add this A vector and minus B vector. Now suppose if I take theta, angle between A and B. Theta is the angle between vector A and vector B. So this is theta. So the angle between A and minus B is given by 180 minus theta, isn't it? Since this forms a linear pair. So by using the same formula of resultant, that R square is equal to A square plus B square plus 2AB. Observe carefully. If I have to add listen, this is actually given by R. We are adding minus B vector and A vector. So we have to take angle between minus B vector and A vector. So here the angle between minus B vector and A vector is cos 180 minus theta and not theta. If you take cos theta here, it means that you are adding vector A and vector B, because theta is the angle between A and B. But we have to add A and minus B. So we will take angle between this A vector and minus B vector, and that is 180 minus theta. Now as you all know, this cos 180 minus theta is minus of cos theta. So this will become minus 2AB cos theta, and this is the formula, dear students. This is the formula. You can take square root to find the value of R, magnitude, isn't it? And you can now easily find the direction of vector, resultant vector, by drawing this diagram, taking angle alpha and applying the same formula as we have used earlier, isn't it? So just keep patience. Now within 2 to 3 minutes we are approaching the numericals and previous year questions. Now special cases, this is very important. So since, let us suppose the special case number 1, when A is parallel to B, it means that this is vector A and this is vector B. Both are parallel to each other. Let us suppose this is A, this is B. So in this case, theta is become equal to 0 and cos theta is equal to cos 0 is equal to 1. So the formula would be like R square is equal to A square plus B square plus 2AB cos 0 1. So this will be 1, and this is actually nothing but A plus B whole square. This is A plus B whole square, implies that R is equal to A plus B. So just add the two vectors, isn't it? I have given the example of the when two forces are acting along the same direction in the box, 10 Newton, 10 Newton, then the force just adds up, giving the resultant vector as 20 Newton. Because both the forces are acting along the same direction, so both has the same tendency to displace the box along the same direction. So just add the vector if they are parallel. Special case number 2, when vector A is anti-parallel to B. Anti-parallel to B. It means that one is suppose along from left to right, the second one is right to left. This is vector A. You can name it, this is vector A and this is vector B. So angle between the two is 180 degree. So cos theta, that is cos 180, is minus 1. So what happens if you apply the formula? R square is equal to a square plus b square plus 2ab. Cos 180 is minus 1, so this is minus 1. So this will be given by a square plus b square minus 2ab. So this will be r square is equal to a minus b whole square, or r is equal to a minus b. So when the two vectors are having opposite direction, then their resultant is given by difference between the two. That's all. And both have the tendency to cancel each other's effects. Third special case, when the first vector is perpendicular to the second vector. That is, suppose this is vector A. This is vector A, 90 degree. This is vector B. So in this case, A is perpendicular to B. So theta is equal to 90 degree, implies that cos 90 is equal to 0. So r square is equal to a square plus b square plus 2ab cos 90. So this whole term becomes 0. So r square is equal to a square plus b square, implies that r is equal to root over a square plus b square. So this is r is equal to a square plus b square, isn't it? Now if you talk about direction, so I will discuss about direction later on. And the last but not the least, that is important case, we have, suppose the two vectors having same magnitude as A, say, and let the angle between them is 120 degree, isn't it? So what happens? R square is given by a square plus, instead of b square we can write a square because both the vectors have the same magnitude, a square plus 2ab, that is 2aa, again a square, and this is cos 120. So as we have learned in trigonometry, to find how can you find the value of cos 120, here I am writing a direct its value, that is given by minus 1 by 2. So a square plus 2a square, its value is minus 1 by 2. 2 gets cancelled, and after that minus a square cancelled. So r square is equal to a square, implies that r is equal to a. So this is very special case where the magnitude of each vector is equal to a, and angle between them is 120 degree, and the resultant magnitude of resultant is also equal to a. This is a special case, isn't it? Now, one more thing I want to share with you is that any vectors having the same magnitude, isn't it? Let us suppose this is vector A having magnitude A. This is vector again magnitude A. So what happens? Suppose the angle between them is theta. Now if I construct a parallelogram and this is showing the resultant vector R, this angle is alpha. So alpha is given by theta by 2. This is very important. Whenever the magnitude of the two vectors are equal and angle between them is theta, then angle made by resultant with any of the two vectors, either of the two vector, is equal to half of theta, isn't it? Because both have the same magnitude. So this is the condition. Both must have same magnitude. The resultant will be from alpha with angle A, and resultant makes alpha with the two vectors. This is alpha, and this alpha is given by theta by 2, isn't it? So this is the special case. Now next. Now components of a vector. As we have, listen, components, suppose here if I take x-axis and if I take here it is y-axis, and suppose I plot a position vector, here it is position vector, this is point P having coordinates x, y, isn't it? Now how can we take component? Suppose here I drop a perpendicular from point P to this line. Here I drop a perpendicular. Now as we know that this is y and this is x. So position vector, this is O. Position vector of point P is given by r vector. So this is given by r vector is equal to x I cap plus y j cap, isn't it? Now this, suppose this angle is theta. So what is not this x is nothing but x component, or you can say I component of vector r. What is y? You can also say this is j component or y component of vector r, isn't it? Now if you observe carefully, this y is given by, or x is given by, this x is given by r cos theta, and y is given by r sine theta, isn't it? So this is very simple, dear students. This is, again, you can apply the same formula, that is trigonometry formula. Sine theta is given by y by r, so y is equal to r sine theta. So any vector, any vector, any vector, suppose this is I am drawing this vector and I am plotting it. Let us suppose this is vector a, and you have to find its component along this line, along this line, let us suppose. So first of all, you have to take angle alpha. So this component drop a perpendicular from here, isn't it? So this component from, let us suppose, OAB. So OB is the component of vector A along the line OB, this one, isn't it? So this is the component of OB. So this component OB is given by A cos alpha, A cos alpha. So this is the first component, and the line perpendicular to this AB, and this will become A sine theta. So these are the two orthogonal components of this vector. Orthogonal means they are perpendicular to each other. A sine theta, the component A sine theta is equal to A cos alpha. Sorry, here we have taken alpha, so this must be equal to alpha. This must be equal to alpha, isn't it? Suppose I plot a graph. If this is a graph and I take a vector here in this way, so how can you take component? Observe the steps very carefully. Drop a perpendicular in this way and drop a perpendicular here. What are the features of these two lines? If this is vector A and this is theta, then component adjacent to theta, this is the component adjacent to theta, is known as A cos theta, and the component perpendicular, this is perpendicular to cos theta, it is given by A sine theta. So A sine theta from here to here, and this is from here to here, this is A cos theta. A sine theta is perpendicular to A cos theta, and here it is the A vector. So in this way we take the value, or we take the components, isn't it? Next, direction cosines. Now one more thing, dear friends. What happens, take a vector here in this, draw a line. This is angle theta, this is angle theta. So we have to take the component of vector A along this line. So the very first step is we have to plot a perpendicular, we have to drop a perpendicular. So we have to drop a perpendicular from the head of this vector to this line, where we are asked to find its component. So this is the line. So we have to find the component of this vector along this line, isn't it? The very first step, what we done, that drop a perpendicular from head of this vector to this line. This angle is 90 degree, and it is very simple. This is from here to here, so this is nothing but A cos theta. So A cos theta is the component of vector A along this line, isn't it? Suppose if I draw a second vector, let us suppose if I draw a second vector like this one, and I take a line, I take a line like this one, I take a line like this one, like this one, and you are asked to find the component of this vector A. This is vector A. You have to find the component of this vector A along this line. So what you do? The very first step is drop. We have to drop a perpendicular, isn't it? So we drop a perpendicular from the head of this vector to this line, and this perpendicular meets this line at M, and let us suppose this angle is theta. So this is given by A cos theta. So what is A cos theta? Any vector, the component of any vector along any line is given by A cos theta. So I am writing here, this is Brahmastra, है ना? Component of any vector A along any line is given by A cos theta, where theta is the angle between the vector A and the line, isn't it? Now suppose if I take x and y axis, so this is, here we have, this is x y axis and this is x axis, and we have a vector like this one, a position vector you can see. And suppose, let us suppose this is x axis, this is y axis. This vector r vector is making an angle alpha with x axis and making an angle beta with y axis. Now if I write component of vector r along x axis, so let us suppose this is point P having x, y. So r vector can also be written as, observe carefully, x I cap plus y j cap. This we have learned earlier, isn't it? X I cap, position vector, is given by this way. And what is x? So this is actually nothing but component of vector r along x axis is given by x, and this x is also given by, so what we do, we drop a perpendicular. Let us suppose this is M. Now this is nothing but equal to x, and also just we have learned earlier that the component of this vector along this line x axis is given by r cos alpha, where alpha is the angle between this vector and the line, isn't it? So x is given by r cos alpha. Similarly, this side is actually equal to y. And if you talk about y, this y is nothing but the component of this vector r along this y axis. So this y can also be given by r cos beta. Why? The component of this vector r along this line, that is y axis, is given by r cos beta, and the beta is the angle between the vector r vector and this line, so r cos beta, isn't it? It's very simple. Y is equal to r cos beta. Now suppose we have a vector r such that r vector is equal to, x I cap plus y j cap plus z k cap. And if I say, if vector r makes an angle alpha, beta and gamma with x axis, with x, y and z axis respectively, then it's very simple. The component of vector r along x axis is given by x is equal to r cos alpha. Why? Because r makes an angle alpha with x axis. It means that angle alpha, that is, it is the angle between vector r and the x axis. So its component along x axis is equal to r cos alpha. Similarly, component of vector r along y axis is nothing but y, and this will be given by r cos beta, isn't it? Because angle beta is the angle between the vector r vector and the y axis. So the component of vector r along y axis is r cos beta. Since we have learned earlier that the component of any vector A, isn't it, along any line A is given by A cos theta, where theta is the angle between that line and the vector. Similarly, if you talk about z axis, then this will be r cos gamma, isn't it? Now, if I ask you about the magnitude of this vector, so as we know, magnitude of vector r is given by, if you remember, what we do, we just take the coefficients and add their squares. So x square plus y square plus z square. In this way, we have find the magnitude. Na? Earlier, just half an hour before, we have derived this formula that r is given by root over, this is the formula of magnitude of any vector, root over coefficient of I cap, square of coefficient of I plus square of coefficient of j cap plus square of coefficient of k cap, isn't it? So r square is given by x square plus, now substituting the formula, we have r square is, we have x square is equal to, this is r cos alpha whole square plus r cos beta whole square plus r cos gamma whole square. So taking r square as common, you have cos square alpha plus cos square beta plus cos square gamma is equal to 1. So this is the formula, isn't it important? And one more thing, as we know that sin square theta plus cos square theta is equal to 1, so for that formula, so this will become 1 minus sin square alpha plus 1 minus sin square beta plus 1 minus sin square gamma is equal to 1. So 1 can cancel, here you are left with 0. So sin square alpha plus sin square beta plus sin square gamma is equal to 2. So this is the second formula, dear students. Now again, since x is equal to r cos alpha, implies that cos alpha is equal to r, x by r. Similarly, y is equal to r cos beta, implies that cos beta is equal to y by r, and z is equal to r cos gamma, implies that cos gamma is equal to z by r. So these are known as direction cosines. These are known as direction cosines. This is very simple. First, you have to find the magnitude of vector r, then take its x, y, and z component and divide the two. You have this direction cosines, isn't it? Now, next slide is, suppose here it is a vector, we have to find its magnitude. So magnitude is given by root over coefficient of I, that is 25 plus 2 square 4 plus 16. So this will be 25 plus 4, 29, and 29 plus 16, that is 45, isn't it? So this can be written as 5 into 9. So this is 3 root 5. So this is A. So first part we have found out. We have to find direction cosines of A. Now direction cosine, that is cos alpha, is x by r. Or here, if here instead of r we have A, so I must write x by A. What is x? That is I component. So this will be 5 by root 5. 5 by 3 root 5. Cos beta, that is y by A. This is given by 2 by A, that is 3 root 5, and cos gamma, this is z by A, that is 4 by 3 root 5, isn't it? So in this way, now find the magnitude and direction of the following vectors. Observe the term, this is not direction cosine, this is just a direction. You have to find the direction. So first, taking the first vector A, let us suppose this is vector A. This is given by 3i cap plus 4j cap. So magnitude is given by root over 3 square plus 4 square. So this will be 5. And as far as direction is concerned, so observe, this is 3 and this is 4. So by for direction, just plot this Cartesian coordinate system. So 3 along positive x-axis. So here, and 4 along positive. So here both are positive. So it will be in first quadrant in this way. This is 3, this is 4, this is alpha, we have to find alpha. So tan alpha is given by, and this is vector A, isn't it? So tan alpha is given by 4 by 3. So in the lecture of basic maths portion, that is the trigonometry class, we have learned that this is a special case 3, 4, 5 triplet. So this is the angle opposite to 4. So here alpha is equal to 53 degree. So we have learned that, and in this triangle this angle will be equal to 37 degrees. So this is the special case, 3 4 5 triplet. Now B is minus 2 I cap, minus 2 I cap. So here one more thing. So what will be the answer? That the direction of A is 53 degree from positive x-axis. Are you getting now? What you write? The direction of vector A is 53 degree from positive x-axis. So in this way we have to write. Now let us suppose vector B is equal to, this is minus 2 I cap plus 2 root 3 j cap. So here again B, magnitude of B is given by 2 square 4 plus 2 root 3, that is 12. So this is root 16 and this is 4. So we have found the magnitude. Now for direction, just draw a Cartesian coordinate. Now this is minus 2 I cap, it means that 2 along negative x-axis. So here 2 along negative x-axis plus 2 root 3. From here you have to shift upward. How much distance? That is 2 root 3. So this is the vector, isn't it? This is the vector B. Now let us suppose this is angle alpha. So tan alpha is given by this side by this side. What is this side? This is actually 2 root 3 y component by this side is 2. This cancel and alpha is equal to 60 degrees. So this is not the final answer. If this angle is 53 degree, observe carefully. If this is 60 degrees, sorry, so then this must be 120 degree. So we say the angle vector B makes an angle 120 degree with the positive x-axis. So in this way you can give the direction. So this two you can also do. Minus 2 I cap, minus 2 j cap. You can solve this well, isn't it? And if you are unable to solve it, just comment, then we will solve it, or I will make a separate lecture for such kinds of questions. Any question if you find difficulty, you can comment. Now this is minus 2 I cap minus 2 j cap. You can easily find the magnitude, that is root 4 plus 4, that is root 8, that is 2 root 2, and this will come in the fourth quadrant, isn't it? Because both are minus value. So coming to the next, an aeroplane takes off at an angle of 60 degree to the horizontal. Let us suppose, dear students, this is horizontal, isn't it? And the direction of aeroplane is initially, it is like this, making an angle 60 degree with the horizontal, and this is the velocity. If the velocity of the plane is 200 kph, kilometer per hour, calculate the horizontal and vertical components of its velocity. So again, we have to find its horizontal and vertical velocity. So first of all, very important, we have to take components of this velocity vector along this line, that is horizontal line, and it makes an angle 60 degree. So component, horizontal component, we have horizontal component is equal to V cos 60, and since vertical is perpendicular to horizontal, so the component, vertical component is given by perpendicular to this component, and perpendicular to V cos theta is nothing but V sin theta. So this will be V sin 60. So if you solve it further, this will be 200 into cos 60 is 1 by 2. So this is 100 kilometer per hour, 100 kph horizontal component. And if you solve this, this is 200 into root 3 by 2. Since this is 100 root 3, 100 root 3, you can take its approximate value 1.732, that is root 3, and this is nearly equal to 173.2 kps. This is vertical components. So that's all for this question. Next is addition of vector by means of component. This is very simple, dear students. Suppose it's A is 2 I cap minus 3 j cap plus 4 k cap, and B vector is 6 I cap plus 3 j cap plus 6 k cap. Now you have to add A plus B. Then add the corresponding components, isn't it? I component 2 plus 6, 8 I cap. J component minus 3 j cap plus 3 j cap. So minus 3 plus 3, 0 j cap, isn't it? And this is 10 k cap. So this is the answer, 8 I cap plus 10 k cap. So you have to add the corresponding components, and that's all. Next. Now you have to find here A plus 2B. So I am going to solve the first question. A plus 2B is given by, so we have to write 2I minus 3, 2I cap minus 3 j cap plus 4 k cap. So this is A, plus 2b. So this is b vector. So we have to multiply it by 2. So 2 6 are 12 I cap minus 6 j cap plus 4 k cap. So this is plus 4 k cap. Now this 2 plus 12 is 14 I cap, minus 3 minus 6 is minus 9 j cap, 4 plus 4 is plus 8 k cap. So that's all for this. Second part, a minus b, you can solve by yourself. Determine that vector which when added to the resultant of. Now first of all we have to add a plus a and b. So we have to find that vector which when added to resultant of, suppose the third vector, determine that vector, I am taking that vector is c vector. So we have to add this c vector to the resultant of a vector and b vector. It means that first you have to add a plus b, and whatever resultant you are getting, add that resultant to the c vector. And after adding these two vector, which when added to this gives unit vector along y-axis, and unit vector along y-axis is j cap. So we have to find c vector. So the c vector is given by, this is j cap minus a plus b. Now this is j cap minus a vector plus b vector is, so this is a, this is b, add the two. So 3 plus 2 5 I cap minus 5 plus 4 minus j cap, 7 minus 3 plus 4 k cap. So this is j cap minus 5 I cap plus j cap minus 4 k cap. So this is j plus j is 2 j cap. So the answer is minus 5 I cap plus 2 j cap minus 4 k cap. So this is the answer, isn't it? Now next, properties of vector addition. So dear student, first property is it is commutative. That is a plus b vector is given by b plus a vector. So this is known as, this property is known as commutative. Order of addition doesn't matter. Second is associative. A plus b plus c. Suppose you add b and c first, then you add a, is equal to a plus b plus c. No matter which vectors, which I mean grouping the vectors doesn't change the resultant. So this known as associative, isn't it? This is known as associative. So these are the properties of vector addition. Now their question, that is AIPMT screen 2010 question. There are 6 vectors. So first of all, just check which statement is. We have to find the correct statement, isn't it? So b plus c is equal to f. Where is b? Here it is b, here it is c. Now suppose if I draw c here, this is c vector. I just shift it vertically. So their resultant must be given by this. So this is b plus c, pointing from this point A to B. But the direction of f is opposite to this value. So this is not correct, isn't it? So this is not correct. So we have like this one. Now second is just check for d plus c is equal to f. Where is d? This is d, and where it is e, sorry, c. C, this is c. So here it is d, here it is c. So this is actually c. Suppose I shift this from this side to this side, d plus c. So d plus c, if I plot a parallelogram using this d vector and c vector, so this diagonal will represent d plus c starting from this point to this point. But as we can see, this vector f is this way, isn't it? So this is again incorrect. Now the third is d plus c is equal to f. D plus c is equal to f. Now this is d and this is vector e, this one. Now if I draw its resultant, so this, it will be like this. So this is giving the resultant d plus e, isn't it? This is e, and the direction of f is also along this way. So this may be the answer. D plus c is equal to f. So option C is the correct. Next, if the magnitude of sum of two vectors is equal to magnitude of difference of two vectors. Dear students, what it's given, that suppose there are two vectors a plus b. So its magnitude addition of is given by, that is the, in this way. This is given. Sum of two vectors magnitude is equal to difference of the two vectors magnitude. Find, we have to find the angle between these two vectors. So we have to find these vectors. So the formula for this is a square plus b square plus 2ab cos theta, where theta is the angle between vector a and b. Now if you subtract, as we have learned from the topic subtraction of vectors, we have the formula a square plus b square minus 2ab cos theta, isn't it? So this a square b square cancel, and after cancelling this you have left with 2ab AB. So you get cos theta is equal to minus of cos theta. It means that 2 cos theta is equal to 0. It means that cos theta is equal to 0. It means that theta is equal to 90 degree or pi by 2 radian. So this is the answer, 90 degree. That's all. Next, the magnitudes of vectors a, b, and c are 3, 4, and 5 respectively if a plus b is equal to c. So I'm again saying you this is a special case in trigonometry. I have said you many times that please go through this special case because this is important case. This is a triangle, dear friends, where if one side is 3, second is 4, so this is with this is the third side, that is 5. This is a special case of Pythagorean triplet, isn't it? This where this angle is 53 degree, this angle is 37 degree. Now let us suppose here it is given that a plus b, this is vector a, this is vector a, this is vector a, this is vector b, a plus b, and this is vector c. You are asked to find the angle between a and b. So this is the direction of b and this is the direction of a. So this angle is 90 degree or pi by 2 radian. So option A is the answer. This is the special case of Pythagorean triplet, right angle triangle. So just to go through the trigonometry lectures, there we have done it. Now particle is moving such that its position coordinates are 2 meter at time t is equal to 0, 6 at time t is equal to 2 second, and at time average velocity from t is equal to 2, 0 to t is equal to 5 second. Since average velocity is given by net displacement by time interval. What is displacement? Change in position by time. And what is change in position? That is final position minus initial position. So here final position is when R2 minus R1 by delta t. Now R2 is given by, observe, the finally object reaches 13 meter, 14 meter at time t is equal to 5 second. So intermediate positions are not having significance while finding the displacement, isn't it? The only two positions are required, that is the initial position and the final position, isn't it? And intermediate positions are not having significance in finding the change in position. So the final position is, that is at t is equal to 5 second, it is having final position, and the initial position is at t is equal to 0. This intermediate position 6 meter, 7 meter at time t is equal to 2 second, it has no significance at all. So final position, so I must write this is 13 meter. So 13 meter means this is x coordinate, so this can be written as in vector form x I cap 13 I cap plus 14 j cap, minus this will be 2 I cap plus 3 j cap, divided by the time interval between the two is t2 minus t1, that is 5 second, minus 0, that is 5 second. Now 13 minus 2, that is 11 I cap, 14 minus 3, that is 11 j cap, divided by 5. So this is the average velocity, that is vector, put vector sign here, that is 1 by 5 11 I cap plus 11 j cap meter per second. So 1 by 5 11 I cap plus, so option D. You can also write 11 by 5 I cap plus j cap. So this is just a simple arrangement, option D is the answer. Next, the velocity of a projectile at the initial point is 2 I cap plus 3 j cap. What is it is indicating? This is x component and this is y component. It means that the direction of velocity from along horizontal component is 2 and vertical component this is 3. So its velocity at point B. So dear students, as per the energy law of conservation of energy, whatever the speed of particle at A and speed of particle at B will be same, isn't it? Because at both the points Both the points are on the horizontal level, both the points are at the same level. So the potential energy, if you take this as reference line, the potential energy at both the points will be same. So the kinetic energy must also be same, so that the total energy will be same, isn't it? So the speed at point A and at point B will be same. So what happens? But one more thing, speed is same, but the direction of velocity, if you observe here, the particle is moving upward, projectile. So its one component is along vertically upward. In position B, the particle is approaching the ground. It's having the same speed. Its horizontal velocity will also be same, that is 2. But the vertical component having the same magnitude as the initial one, but its direction is towards negative, that is towards downward direction, that is negative y-axis. So here if I write its velocity, so it will be like 2 I cap minus 3 j cap. So this will be the answer, that is C, 2 I cap minus 3 j cap, isn't it? So this is the concept of projectile actually. Now the product of two vectors. Now we have two different kinds of products. The first one is there are two kinds of vectors we have, that is the first is dot product and the second is cross product. So first let us have a look at dot product, isn't it? So dot product is given by, suppose there are two vectors A dot B. So this is given by A B cos theta. Suppose this is vector A, this is vector B, so this is given by theta, isn't it? So this is very simple formula. This is A dot B is A B cos theta, isn't it? And also what is A? A is the magnitude of vector A, B is the magnitude of vector B, and theta is the angle between the two. Similarly, if you write B dot A, it is given by BA cos theta. Same thing. Magnitude of B, magnitude of vector A, and cos theta. So from here you have A dot B is equal to B dot A. So this is known as commutative property. Order doesn't change. I mean, by changing the order, result doesn't change, isn't it? Now, let us suppose if I take the unit vectors, dot product of unit vectors. So if I write I dot I, so what happened? Magnitude of first vector, then magnitude of second vector. I itself is a second vector here, and the angle between the two, since both are I cap, so angle between the two is 0. So this is 1, magnitude of I cap is 1, cos 0 is 1, 1. So I dot I is 0. Similarly, J dot J and K dot K, it is also equal to 1. So when unit vector multiplied by itself, it gives the value 1, isn't it? So this is the key point. Now if I write I dot J, so this will be magnitude of first vector, magnitude of second vector, and angle between the two is 90, because one is pointing along x-axis and the second is pointing along y-axis. So the angle between the two is 0. So this will be 1 multiplied by 1 multiplied by 0 is equal to 0. So this is the special result we get, that whenever unit vector multiplied by another unit vector, the product is 0. है ना? The product is 0. But when it is multiplied by itself, it gives it gives equal magnitude equal to 1, isn't it? So this is the special case. Now what happens? Let us have some examples. Suppose if I write A vector is equal to 2I cap plus 3j cap plus 4k cap, and B vector is equal to 6I cap minus 2j cap plus 4k cap. Now what happens if I wish to find A dot B? So in first bracket we write 2I cap plus 3j cap plus 4k cap. In second bracket we will write 6I cap minus 2j cap plus 4k cap. Now what happens if I multiply 2I cap 6I cap? So it will be like this is 2I cap dot 6I cap. So here 2 into 6, this will become 12 and I dot I become 1. But if I multiply 2I cap with this j component, so 2 into minus 2 will become 4, no doubt. But I dot j will become 0, as we have found it earlier. I dot j 0. Because I is having dot product with j, that is different unit vectors. So give the result 0. So it means that finally You have to multiply only the corresponding components. This is the beauty of dot product, isn't it? And this makes it easy. So we have to find, so we have to multiply the 3j cap only with the j component, and this will be minus 6. Why? Because j dot j becomes 1 and 3 into minus 2 is 6. If you multiply 3j dot 4k, then j dot k will become 0, isn't it? Then no matter 3 4s are 12 become, because j dot k will become equal to 0. So whenever you multiply, or you can say whenever you take dot products of two different unit vectors, it will be 0, and by itself it will be equal to 1, isn't it? So 4 4s are 16. So finally you will get, this is 12 minus 6, 6 plus 16, that is 22. So this is the result, or this is the answer, isn't it? Now next is properties of dot product. So dear students, it is commutative, that is a dot b is equal to b dot a. Acha, one more thing, na, one more thing. Finally, if we have found the value of a dot b, and the final value we are getting without any I, j and k component. So we are getting the value only magnitude. So that's why the dot product is giving the scalar product, that is only magnitude product. So we say that dot product, that's why dot product is also known as scalar product. And in the introductory session of this lecture, I have said about the scalar quantity, that scalar quantity is nothing but dot product of two vectors, isn't it? So next is properties. So this property is known as commutative, and one more property is a dot b plus c is equal to a dot b plus a dot c. This property is known as distributive, isn't it? So these are the two properties. Acha, there are confusion in many students, that does it follow associative rule, as we have seen in the properties of addition. So remember dear student, this is not equal to a dot b dot c, है ना? Why? Listen, because dot product are the product of two vectors. Listen carefully. But this, when you solve this b dot c, this will become scalar. Now how can you take dot product of one scalar and one vector? Isn't it? So this statement is actually doesn't make any sense, isn't it? This can be happen that if you write k a dot b, so this can be happen that ka dot b in this way, where k is a magnitude, where k is a scalar, isn't it? Now if a plus b, so these are the properties, and on the basis of properties we have some more examples, and on the basis of these examples we are going to get the new results, isn't it? So if a plus b dot a minus b is equal to 0, then a is equal to, so we have to prove a is equal to b. The condition is this, isn't it? So first of all, on the basis of distributive property, that this will be a dot a plus this a, or you can say minus a dot b plus b dot a minus b dot b. So this AB is equal to BA by the commutative property. This A dot A is nothing but magnitude of vector A, and angle between the two vectors, that is 0. So this will be A square. So whenever dot product of vector, है ना, when multiplied by itself, that is A dot A is giving value A square. Similarly, this minus B dot B is giving the value B square is equal to 0, implies that A square is equal to B square, implies that A is equal to B. So this is the value. The second is R and AB. This is the relation. For example, we have, let us suppose this is A and this is B. Let us suppose this is vector R. So what is the formula for R magnitude or R square? This is given by A square plus B square plus 2AB cos theta. So instead of this 2AB cos theta, we can write A square plus B square plus 2A dot B, isn't it? So this is R, magnitude of R vector. This is the formula. Next, A is equal to I cap plus J cap, B is equal to I cap plus K cap. And listen, Now it's a very important topic. Now if you observe carefully, what is dot product? Now let us suppose I am drawing two vectors, a vector and b vector. Very important topic, dear friends, very important. This is a vector and this is b vector. Observe carefully. This is vector a and this is vector b. Now an angle between the two is theta. Now what is actually this I mean a dot b? So a dot b is given by a into b cos theta. Now observe carefully, very important topic. Here it is the scale. Now if I drop a perpendicular, isn't it? If I drop a perpendicular from the head of the b to this point n, if I name it as n, so the a vector is from o to this point a. But if I drop a perpendicular from the head of this b to this line OA, then this value, since I am dropping the perpendicular from this head of the vector A, so this value, you know, this is nothing but component of vector B along the side OA, and this is given by B cos theta. Just 15 to 20 minutes before, we learn how to take the component of any vector along any line. So here, what was the procedure? First, we drop a perpendicular from the head of this vector to this line. Suppose the perpendicular meets this line at point M, then this OM will give the component of vector B along this line OA. So this is B cos theta. So dear friends, what is this B cos theta? This B cos theta is component of vector B along this line OA. And what is this OA? This is nothing but vector A. So what is B cos theta? Component of B along vector A, or this can be written as projection of, this is also known as projection of vector B on vector A. So this B cos theta, now again coming to this equation, A dot B is nothing but, this is A into component of B vector along A. So from here you can find the component of vector B along A, and this is nothing but component of vector B along vector A is given by A dot B by A. This is very important. Instead of, if in question it can also use the word that is projection of B along A. Similarly, if I write component of vector A along vector B, so this is nothing but A dot B by B, isn't it? So you observe this formula carefully. The numerator is fixed, that is A dot B, and in denominator you have the magnitude of that vector along which you have to take the component. So here along A we have to take the component, so we divide it by A. Here we take the component along B, so we divide it by B, isn't it? And this is the component of vector A along B. So here A vector is given as and B vector is given as this value. So how can you solve it? Let us take A dot B, isn't it? So you can, to find the angle between the two vectors, you can use dot product. So from here we get cos theta is equal to A dot B by AB. Now A dot B is, so here I dot I, that is 1, plus J dot K is 0. A is the magnitude of vector A, so its magnitude is root over the coefficient of I is 1, J is 1. So this is 1 square plus 1 square is equal to root 2, and this is also having same value, root 2. So this is root 2 multiplied by root 2, so this is 1 by 2. Since cos theta is equal to 1 by 2, it means that theta is equal to 30 degree, isn't it? So go through the trigonometry lectures if you are confused with this value, isn't it? Now geometric interpretation of dot product. Dear students, what we have learned just 2 minutes before, that is projection of vector A over B or projection of vector B over A. This is known as geometric interpretation of dot product, isn't it? So A dot B is nothing but A multiplied by component, or you can say projection. You can use two words, projection or component, b cos theta of vector b along the direction of vector A. Similarly, isn't it? So this is nothing but geometric interpretation that we have already done. Next is, what is the magnitude and direction of vectors this value? What are the components of a vector along the direction? So this question has two parts. The first part is, we have to find the magnitude and direction of vectors I cap plus j cap and I cap minus j cap. So let us suppose the first vector is x vector, that is I cap plus j cap, and the second vector is y vector is equal to I cap minus j cap. So first we have to find its magnitude. So its magnitude is given by root over 1 square plus 1 square, since the coefficient of I and j are 1 and 1. So this is root 2. Similarly, magnitude of second vector is also root 2. Now we have to find its direction. So for direction we have this value. So this is 1, this is 1. So the vector is like in this value, first quadrant, and this angle is alpha. This is 1, this is 1. So tan alpha is equal to 1. It means that alpha is equal to 45 degree. That is, the vector x is at 45 degree from the positive x-axis. Such kinds of questions just we have done 30 minutes before, isn't it? I cap minus j cap. What you do? I cap, that is 1 along positive x-axis, minus j cap, that is minus 1, isn't it? So 1 along negative y-axis. So this value. So this is the vector. So here this is the vector, isn't it? Now you can take this angle as alpha. So this is 1, this is 1. So this tan alpha is given by 1 by 1, and this alpha is equal to 45 degree, isn't it? So this is 45 degrees. So this value from positive x-axis, if you take, so this value will be given by 360 minus 45 degree. So this will be 350, 340, 330, that is 315 degree. So the direction is 315 degree from the positive x-axis. So this alpha, you can listen. This answer can be represented in two ways. You can write 315 degree from x-axis, that is positive x-axis, or you can write minus 45 degree from x-axis. Why I put minus here? Because in the trigonometry lecture of basic maths, we have learned that since this angle alpha is taken in clockwise order, here it is the x-axis, that is the reference line, and this line. So we come in clockwise manner. So this angle is minus 45 degree. Are you getting? So this is. Now cross product. Second product of vector is, that is cross product, and this is given by a vector cross b vector, magnitude of first vector into magnitude of second vector, then sine of angle between them, and n cap. Since this value AB sine theta is having magnitude and n cap is providing or giving direction to this magnitude, so whatever result we are getting, it is a vector quantity because of this n cap. That's why this is also known as vector product. And any vector, there are many vector quantities which can be written in the cross product, that is torque. Tau is equal to r cross f. We have seen in the introductory session of this lecture. So this is AB sine theta n cap, where the direction of n cap, definitely it is along A cross B, and its direction is found out by right hand thumb rule, or in many literatures you have that screw rule, isn't it? So how can you find this direction? So let us suppose if here it is A vector and this is B vector. This is vector A and this is vector B, and this angle is theta. You have to find the direction of A cross B, isn't it? So first of all, open your right hand, isn't it? Now direct these fingers along the first vector. Suppose you have to find the direction of A cross B, A cross B. So first vector is A vector. So stretch the fingers of the right hand along the first vector, that is A vector. Then curl the fingers towards B. So I am curling the fingers towards this B, isn't it? then stretched thumb will give the direction of A cross B, or you can say stretched thumb will give the direction of n cap. So this stretched thumb will be perpendicular to this plane of the board in which vector A and B lie, isn't it? And outward from this board, because we are taking A into B, isn't it? So what happened? The direction of A cross B is perpendicular to plane of the board and away from it. Perpendicular to plane of the board, and if you are writing on paper, then perpendicular to the plane of that paper and away from it. And away from it, isn't it? So direction of n is also, n cap is also the same. Here n cap, we can read it as n cap. So now suppose, so the direction of A cross B, dear students, direction of A cross B is perpendicular to this plane of the board and away from the board, that is towards you. It is like an arrow is approaching towards you, perpendicular to this board. So you are observing, or you are looking at the pointed end of this arrow. So we will represent it in this way, putting a dot inside the circle. So it is, this direction is perpendicular to plane of the board or paper and away from it, and away from it. It is like arrow is approaching towards you, so you are looking at this pointed end. Now if I write cross sign, so it is representing perpendicular to plane of the board or paper and into the board or paper. So it is like, the direction of B cross A is like this one, isn't it? Now when you find B cross A, so we take the fingers along B, then curl it towards A, then stretch thumb will give the direction of B cross A, so that is into the board. So it is like the arrow is going away from you and into the plane of this board. So you are observing this feathered end of the arrow. That's why this sign is here, isn't it? So B cross A. So dear students, what is the difference between A cross B and B cross A? A cross B is given by AB sine theta n cap, isn't it? And B cross A is having the same magnitude, but direction is opposite to this n cap, so this is minus n cap. So are you getting, both are having the same magnitude but their direction is different, so we can write A cross B is minus of B cross A, since as we all know that this minus sign before the vector represents the reversal of direction. Since B cross A is having the same magnitude as B, but its direction is opposite to A cross B. So if I put minus here, so what happens? Its direction will be opposite to B cross A, and that is gives the direction of A cross B, isn't it? So this is very important expression. If you put minus here, then both will become same. Magnitude wise still they are equal, and if you put minus sign here, then their direction will also become same. So this is the fundamental. Now what happens, how can you find A cross B, isn't it? So there is a particular method, but before going to that method, let us have some look at properties. The very first property is, since dot product follow commutative property, but cross product doesn't follow, isn't it? And the second is, it also not follows the associative, but it also follows the distributive law, that is A B plus C is equal to A cross B plus A cross C, isn't it? These are the properties. Now let us have some examples. How can you find the cross product? Suppose A vector is equal to 2i cap plus 3j cap plus 6k cap. B vector is equal to I cap minus j cap plus k cap. We have to find A cross B. So the method is, we follow the determinant method. First of all, we write the elements of A vector. So the very first step is put I cap here, j cap, k cap. So we have to write the elements of vector A first, now, because A cross B. So the elements of vector is corresponding to I, we have 2, this is 3 and this is 6. Then we write elements of vector B. The coefficient of I cap is 1. Here it is -1 and here it is again 1. So we have to find this value. Now observe the sequence. Now what we do. So here A cross B is equal to, so first we write I. So remember the circle, dear students. This is I cap, then J, and then K. So we have to follow this pattern. After I, J, after J, K, and after K again I, isn't it? So what happens? First of all, here put I here. Then since this is first row and this is first column, so hide the column of I cap, and after I what comes? J. Then observe the elements of J and then observe the elements of K. So just write this value 3, 6, -1. This value 3, 6, -1 and 1. So observe this value. So right here 3, 6, -1 and 1 plus right here J cap, isn't it? Now what you do? Hide the elements corresponding to J cap. Now after J, K comes. So write first the elements of K here 6, 1, and then write the elements after K I comes, then write the elements to 1, isn't it? Then after J, K comes here. Then while writing elements K, hide this element corresponding to K, and after K comes I, isn't it? So write its element 2, 1, and this is 3, -1. So this is the very first step. Second is, now you have to take the cross multiplication, isn't it? You have to multiply this value with this one, this value with this one. How you can approach it? Let us see. So this is here I cap, put a square bracket, multiply this cross numbers. So here this is 3, here this is 1. Minus, multiply this cross numbers. This is 6 and this is -1. Close the bracket. Plus J cap. Now take this cross numbers, that is 6, 1 minus 2, 1 plus this is K cap 2 -1 minus 3, 1, isn't it? So finally you will get I cap. This is 3 -6 -1 plus 6 plus 6 plus J cap. This is 6 -2 plus K cap -2 -3. This will be 9 I cap plus 4 J cap -5 K cap. So this is the answer, A cross B vector. In this way you can find. Now let us have cross product of unit vectors. This is very important. Just we have taken the dot product of unit vectors. Here we are writing cross product of unit vectors. So this is, if I write I cap cross I cap, I cap cross I cap. So this is magnitude of I cap, then magnitude of I cap, and angle between the two. So angle between I cap and I cap is 0. So its magnitude will be 0 because sine 0 is 0. Then whole will be 0. Now here if I take I cross J, this is x axis, this is y axis, and the axis perpendicular to the board of the plane of the board and coming towards you is z axis, isn't it? This is x, this is y. Here it is I cap, here it is J cap, and if I circle in and put a dot, then this is representing K cap. That is the direction of the K cap is perpendicular to this plane of x and y, that is perpendicular to this plane of the board and coming towards you. This is J cap, dear students, isn't it? Now if I write I cap cross J cap, so what happens? First of all I write the magnitude of I cap, then magnitude of J cap, angle between the two. Angle between the two is sine 90, isn't it? And then we put n cap. What is the definition of this n cap? It is along the direction perpendicular to the plane of this x and y, that is the plane of the vectors I and J cap, isn't it? And away from it, and you can find it by using the right hand thumb rule. So direction of n cap is given by, this is I cap, this is J cap, I cross J, and this is stress thumb. So this is n direction of n cap, that is along K cap. So this is nothing but unit vector along z axis, or you can say positive z axis, by using the rule, right hand thumb rule. Put this fingers of right hand along x axis, then curve along y axis, then stress thumb will give the direction of this n cap. So this is along the z axis. So this is unit vector along z axis. And what is unit vector along j axis? It is nothing but k cap. So I cross j will become k cap. So observe the pattern as I have written earlier. This is I cap, j cap, and this is k cap. If you go through the sequence, I cross j will become k, and similarly if you found this j cross k will become equal to I, and k cross I will become equal to j, isn't it? So these are the formula. Now if you reverse the pattern, that I cross j is equal to k, then j cross I will become equal to minus k. J cross k is equal to I, then k cross j is equal to minus I, and k cross I is equal to j. It means that I cross k is equal to minus of j. So in this way you can find the cross product of unit vectors. Next is area of parallelogram and triangle. What happens, dear friends? Suppose we have a parallelogram like this one. We have a parallelogram. Now suppose the sides of parallelograms are represented by two vectors. So this is vector A, and this is vector, this is vector B, and angle between the two is given by theta. Now if I plot a perpendicular here, if I plot a perpendicular from here this way, so this will become M, and let us suppose, so if this is B, so this height is given by B sine theta. B, because this is perpendicular, this is right angle triangle, this is theta, so this is B sine theta. So if I write area of parallelogram, this will be A, this is side length, base is A multiplied by height. This is the area of parallelogram. And here, so this is equal to height h, and here it is given by AB sine theta. So this AB sine theta is nothing but A cross B, magnitude of A cross B, isn't it? So area of parallelogram is magnitude of A cross B. Similarly, if you wish to write area of triangle, then you can draw any triangle. I am drawing it by rough. This is A, this is B, isn't it? This is theta. So this height is given by again B sine theta. So area of triangle is given by half base into height. So this will be half AB sine theta, that is half A cross B magnitude. So this is the area of parallelogram in terms of cross product. Next, now we have question, the position vector of a particle is given by r is equal to a cos omega t I cap plus a sin omega t j cap. The velocity of the particle is. So the position vector, first of all I am writing here the position vector. So position vector is given by a cos omega t I cap, plus a sin omega t j cap, We have to comment on the velocity. This is position vector is given. So since we know that velocity is given by dr by dt, so we have to differentiate this value. So this is nothing but d by dt of a cos omega t I cap plus d by dt of a sin omega t j cap. On further solving, we get on differentiate. This is constant. Take it outside from the differentiation. Differentiation of cos omega t is minus sin omega t, and after omega, this is the case of function, as we have learned in go through the lecture where I have covered the differentiation portion, where we have learned how to approach this such kinds of differentiation where there is more than one function. Here it is a cos function, and inside cos function there is a linear function, that is omega t, isn't it? So first we differentiate this cos function, we will get minus of sin omega t, and then we will differentiate this omega t, then we will get omega, and here it is a. So this will be minus a omega sine omega t I cap plus this is a omega cos omega t j cap, isn't it? So this is the formula of velocity, and we have to comment on the velocity of the vector. Now these are the options. The first option is directed towards the origin. Since, listen, first of all I am writing it, this is minus a omega sine omega t plus a omega cos omega t. So dear students, what happens, let us first comment on the, remember the earlier 30 minutes of this lecture where we have found the direction of position vector. Since the direction of position vector is always away from the origin, so it is directed away from the origin. Away from the origin. Now, if this velocity vector is directed towards the origin, it means that it is having direction opposite to position vector. It means that if it has direction towards the origin, then it can be written in something like this one, v is equal to minus of some constant multiplied by r vector, isn't it? So you can write this in this way. Observe carefully. Suppose you have taken omega outside. From here you have taken omega outside. So you are left with minus a sine omega t plus a cos omega t. Now observe this value. Here we have the term cos omega t I cap, and here we have the term sine omega t I cap. Here we have the term a sine omega t j cap, and here we have the term a cos omega t j cap, isn't it? So whatever arrangement you do, but it will never equal to this value. I mean, it never gives the value that is some constant multiplied by position vector is equal to velocity vector, isn't it? So neither it will directed towards the origin nor it will directed away from the origin, because in both the cases it must satisfy the relation v is equal to k times position vector. If k is negative constant, then v is opposite to the direction of position vector, that is towards the origin, and k is positive constant, then what happens, velocity is away from, that is velocity is having same direction as position vector, that is directed away from the origin. But what happens here, if I observe the expression of this velocity vector, it can never convert into this way. Observe carefully. Here in the coefficient of I cap we have sine omega t, here we have cos omega t, here we have cos omega t, here we have sine omega t with the j cap. So this is never possible. So the two options, directed towards the origin and directed away from the origin, is cancelled. The second thing again is parallel to the position vector. This is also gets cancelled, because if it is parallel to the position vector, then it must along the same direction as the position vector, that is away from the origin. And same case, whenever the two vectors are parallel to each other, then they may be written in this form, that is a vector is equal to k times b vector, where k is a positive constant, then we can say the vector a and b are parallel to each other. But here velocity cannot be equal to k times r vector. Why? This is r. Why? Again the same thing, we have the expression in this way. So this can also not happen, isn't it? So the one option remains is that is perpendicular to the position vector. So this option may be the right answer, but we just check it though it is right or not, isn't it? So how can we check that the two vectors are perpendicular to each other? Take its dot product. If the dot product is 0, then we can say that the two vectors are perpendicular to each other. So I am writing here v dot I. I am finding here v dot r vector. So v vector is given by minus a omega sine omega t I cap plus a omega cos omega t j cap dot r vector is given by a cos omega t I cap plus a sine omega t j cap. A cos omega t I cap plus a sine omega t j cap. We have the property na a dot b is equal to 0 when a is perpendicular to b, because it will become ab cos 90 and cos 90 is 0. So what happens, as we have learned that I coefficients are getting first multiplied. So this is a omega sine omega t, a omega cos. So this will be minus of a square omega sine omega t cos omega t plus multiplied the coefficients of j cap. So here a square omega cos omega t sine omega t. So observe carefully, minus a square omega sine omega t cos these are equal and opposite, so this will be 0. So we can say that since the dot product of position vector and velocity is 0, so velocity must be perpendicular to position vector. Second is a particle moving with velocity v is acted by three forces. This is force 1, this is F1 vector, F2 vector, and this is F3 vector of triangle. The velocity of the particle will. Since to find the velocity of the particle, we have to first find the acceleration, net force. So net force is given by, this is F1 vector plus F2 vector plus F3 vector. So dear students, F1 is starting from this point, that is point Q. So you go to the point R, that is F1 vector, F2 vector, and finally this is F3 vector. So just take it, this is as F2 and this is a F3, just by following the sequence, isn't it? It doesn't change the answer, but this is F1 vector, F2 vector, and F3 vector. So starting from point Q, and finally you again reach the same point, so the net vector or the net force will be given by 0 vector. So the force, 0 force is acting on the object. So as per the law of inertia, its velocity will remain unchanged, that is constant. So this is a very tricky question, isn't it? In this expression, the position vector is given by this value. There are 4 statements. We have to select the wrong statement, isn't it? So very first it is commenting about acceleration. So we have to find the acceleration, expression for acceleration. So as you all know, dear students, what is velocity. So to find acceleration, we have to find first velocity, because acceleration is dv by dt, where v is velocity. So here v is given by, so if you differentiate this position vector, then you will get the expression for v. So by differentiating it, we will get, this is 8 pi cos 2 pi t I cap minus 8 pi sine 2 pi t j cap. If anyone finds difficulty in differentiating it, then just go through the differentiation lecture, isn't it? This is the expression for velocity, and to find acceleration, we again differentiate it, isn't it? So this will be 16 minus 16 pi square sine 2 pi t I cap. This is minus 16 pi square cos 2 pi t j cap. So here we are applying the chain rule for differentiation. So here you can take common as minus 4 pi, and in the bracket you will have 4 pi sine 2 pi t I cap plus 4 pi cos 2 pi t j cap, and this is nothing but position vector, so this will be minus 4 pi r vector. So here we are observing that this acceleration vector is given by minus of constant multiplied by position vector. It means that this minus is relevant to the direction, isn't it? So this acceleration is opposite to the direction of position vector, or you can say acceleration is along minus of r vector. So this statement is right. What is the significance of minus sign? We have already covered in this lecture, isn't it? Now magnitude of acceleration. Now we have to find magnitude of acceleration, and it is given by v square by r. So let us check first v square by r. So v square by r, that is magnitude of velocity, isn't it? Square of magnitude of velocity. So as you all know, the magnitude of any vector is given by x square plus y square plus z square, where x, y and z are the coefficient of I cap, j cap and z k cap respectively. So here v square, so this is the expression of v, isn't it? So v square is given by 8 pi cos 2 pi t square plus 8 pi sine 2 pi t square, and the magnitude of r vector is given by, this will be 4 sine 2 pi t square plus 4 cos 2 pi t square. Now if you solve this, observe carefully. This 8 pi square, you can take 8 pi square common. So outside you will have 64 pi square, isn't it? Inside the bracket, this will be cos square 2 pi t plus sin square 2 pi t, and that is equal to 1. Sin square theta plus cos square theta is 1. Similarly, here under root, you have this 4 square as common. So this will be 16. And within bracket, sin square 2 pi t plus cos square 2 pi t again equal to 1. So this will be 64 pi square. 64 pi square divided by root 16 is 4. So ultimately, you will have this will be equal to 16 pi square. So what is the value of v square by r? That is 16 pi square. Now let us check acceleration. So acceleration, it is given by acceleration. Expression for acceleration is that is 16 pi square. So this will be 16 pi square cos 2 pi t square plus 16 pi square sine 2 pi t square. So dear students, again 16 pi square, take it as common outside, and it is under square root. So outside the root you will have only 16 pi square, and inside the root we will have cos square 2 pi t plus sin square 2 pi t, that is equal to 1, and root of 1 is 1. So this will be 16 pi square. So both value are equal. That is, expression for magnitude of acceleration is equal to magnitude of v square by r. So this statement is also right. We have to select the wrong one, isn't it? Magnitude of velocity of the particle is 8 meter per second. So let us find the magnitude of the velocity. So observe carefully. Here in numerator we have found the square of magnitude of velocity, and that comes as 64 pi square, isn't it? So if I wish to find velocity, then take its square root, 64 pi square, and this will be given by 8 pi meter per second. So here the magnitude is given as 8 meter per second, but actual velocity magnitude is equal to 8 pi. So this statement is wrong, and this is the answer. So option C is the answer, isn't it? And path of the particle is a circle of radius 4 meters. So let's discuss it because it has concept, isn't it? So let us find. Now, if the question is saying that path of the particle is a circle, what does it indicate? It indicates, if the path of a particle is a circle, then what happened, dear student? This is the origin, isn't it? This is the origin. If the path of the particle is circle, then the position vector, suppose the particle is at point P1, this is point P1. Suppose the particle is at point P2. Suppose the particle is at point P3. If the path traversed by particle is a circle, then magnitude of position vector must always remain same, isn't it? If this value is 4 meter, then this value must also be 4 meter, this value must also be 4 meter. Wherever particle goes, its position vector magnitude must be equal to same, isn't it? Only then you can say that it is following a circular path. Why? Because the magnitude of this position vector will be equal to radius of this circular path. So let us check the magnitude of position vector. If it is equal to 4 meter, then we can say that it is following a circular path. So this will be root over 4 sine 2 pi t square plus 4 cos 2 pi t square. So this will be 4 square, take outside from the root. So this will be 4. Inside root you have sine square 2 pi t plus cos square 2 pi t, that is equal to 1, and root of 1 is 1. So definitely the magnitude of position vector is given by 4 meters. It means that wherever particle is moving at any instant, its position is given by 4 meter, isn't it? So it must, and this position is from the origin. So it means that the particle is traversing a circular path and its center is at the origin. So the last statement is also correct one, isn't it? So the correct option for this answer is option C. Next, in this question, so this is actually, if you observe, it is almost same pattern from the earlier question. A particle moves so that its position vector is given by this value. Which of the following is true? We have to find the correct statement. So first it is commenting about on the velocity, isn't it? So what is velocity? So velocity is given by v is equal to, you have to differentiate this value. So this will be minus omega sine omega t x cap plus omega cos omega t j cap. We have to check whether it is perpendicular to r vector or not. So to check it, what we need to do, we need to find if v dot r is equal to 0, then we can say that v is perpendicular to r vector, isn't it? Because we are cos 90, we have learned in this lecture that this will become v r cos 90, cos 90 is 0. So we have to find this value. If this is 0, then we can say that v is perpendicular to r vector. So let us find v dot r, isn't it? So v vector is given by minus omega sine omega t minus omega sine omega t I cap plus omega cos omega t j cap dot the Acha, this is not I cap and j cap. In this question it is given as x cap and y cap. So put here x cap and here y cap dot the velocity is I mean the position vector is given by cos omega t x cap cos omega t x cap plus sin omega t y cap, sin omega t y cap. So here we have, as we know the rule of dot product, so x cap, so this will be minus omega sin omega t cos omega t plus omega cos omega t sin omega t, and you can easily see that these two terms are having same magnitude, with one is minus, second is plus, so this will be 0. So since v dot r is 0, implies that we can say that v is perpendicular to r vector. So this is right. And the second is acceleration. In this statement, one statement also attached that acceleration is directed away from the origin. So always remember, when we are in this lecture, when we are learning about the position vector, then we have said that the direction of position vector, that is position vector, is always directed away from the origin, because it starts from the origin and approaches that point for which we have to find the position vector. So if I say that acceleration is directed away from the origin, it means that acceleration is along position vector, isn't it? So first we have to find the acceleration, expression for acceleration. So what is acceleration? Acceleration, it is nothing but dv by dt. So we have to differentiate the velocity, this value, so minus omega. So this expression is, if you differentiate this, so this sine gets converted into cos omega t. Differentiation of omega t is omega, so this will be minus omega square cos omega t. So if you find difficulty in differentiation, then please go through the lecture of differentiation, dear students, isn't it? So this will be minus omega square cos omega t x cap plus omega square x cap, and then this will be, if you differentiate it again, so this will be minus omega square sine omega t y cap. Now you can take common as, so here observe carefully, this cos omega t x cap plus sine omega t y cap, this is nothing but position vector. So if I take common here minus of omega square, then this will be cos omega t x cap plus sine omega t y cap. So this is nothing but r vector. So acceleration is given by minus omega square r vector. So it means that the direction of acceleration is opposite to position vector. It means that if position vector, direction of position vector is away from the origin, so the direction of acceleration must be towards the origin. But here it is given the direction is towards the origin. Yes, velocity is perpendicular to r vector and acceleration is directed towards the origin. This is the answer. The first option is the answer, isn't it? In the second case, velocity is given but acceleration is directed away from the origin. This is wrong. Velocity and acceleration both are parallel to, so no need to check these options, just option is the correct one, isn't it? So mark it and move further. If a vector 2i cap plus is perpendicular to this vector, value of alpha is, you have to find value of alpha. So dear students, if these two vectors are perpendicular, so what, their dot product must be equal to 0. That is 2i cap plus 3j cap plus 8k cap dot 4j cap minus 4i cap plus alpha k cap. This should be equal to 0 if they are perpendicular to each other. So let us find this. So this is the coefficient of I cap is 2, here coefficient of I cap is minus 4, so this will become minus 8, isn't it? and this is minus 8. Coefficient of j cap is 3. Here the coefficient of this will be 12. Here k cap coefficient is 8 and k cap coefficient is alpha. Now what is it is actually given that it is perpendicular to this value, so this must be equal to 0, so this must be equal to 0. It is given now, so their dot product must be equal to 0. So 12 minus 8 is 4 plus 8 alpha is equal to 0. It means that 8 alpha is equal to minus of 4. So what does it indicate? This is minus 1 by 2 or minus 0.5. So minus 1 by 2 is the correct answer. So B option, isn't it? So just use this property. If these two vectors are perpendicular, then their dot product must be equal to 0. That's all. Next, if vector A is equal to, again this question is kind of the same question, but different things are being asked in different years, isn't it? If vector A is given by this value, B is given by this value, are functions of time, then the value of t at which they are orthogonal to each other. The value of t at which they are orthogonal. So if they are orthogonal means they are perpendicular to each other, isn't it? And if they are perpendicular to each other, then their dot product must be equal to 0. So we have to put the dot product equal to 0 and then we can find easily the value of t, isn't it? So their dot product is, this is cos omega t, coefficient of I cap and cos omega t by 2. So this will be cos omega t into cos omega t by 2, isn't it? Yes, cos omega t by 2. And then I'm taking it little down so that here we can have the space. Second, j cap coefficient is sin omega t. Here it is sin omega t by 2. So this will be sin omega t and this is sin omega t by 2. And this must be equal to 0. This must be equal to 0 because the dot product is given as 0. And we have to find the value of t. So if you observe carefully, this is cos A cos B plus sin A sin B. So this in the trigonometry we have learned a formula that cos A cos B plus sin A sin B is given by cos of A minus B. So here A is omega t and B is minus omega t by 2. So this will 0. It means that omega t minus omega t by 2 must be equal to pi by 2, isn't it? Why? Because cos 90 is 0, so this is pi by 2. Now on solving it, we will have, and as we know that this omega is given by, here it is given in the question or not, are orthogonal, isn't it? We have to find. So what will be, this will be omega, this is t minus t by 2 is equal to pi by 2. So this will be t minus t by 2 is t by 2, omega, shift omega right side, so this will be pi by 2 omega, so t is equal to pi by omega. So this is the expression. So t is equal to pi by omega, option A is the correct answer, isn't it? So these are the simple questions, these are, dear students, isn't it? I was just looking for whether the omega, the value of omega is also given something or not, but here the expression of t term is, I mean we get expression of t in terms of omega. If there is given the value of omega 2, 4, then we put the value of omega in this expression, isn't it? A particle from, so this is displacement, initial position is this one, this is final position. So this is r1, you can say initial position, this is r2, you can say final position. So the change in position vector, that is delta r, is given by r2 vector minus r1 vector. So this is actually 4 j cap minus 5 j cap. So this is minus of j cap, and this is, here we have 3 cap, here no 3 cap, so this will be plus 3 k cap, and here no I cap, minus minus, so this will be 2 I cap. So the expression will be like this one, r2 vector minus r1 vector is 2 I cap minus j cap plus 3 k cap, and the force applied is given by 4 I cap plus 3 j cap. How much work has been done by the force? So force is given by F dot displacement, and what is displacement? This is nothing but change in position. So this force vector is 4 I cap plus 3 j cap dot This is 2 I cap minus j cap plus 3k cap. 2 I cap minus j cap plus 3k cap, isn't it? Now solve it. Coefficient of I cap, coefficient of I cap 8, coefficient of j cap, coefficient of j cap, that is minus 3, coefficient of k cap 3, no coefficients of k, component of k, so this will be 8 minus 3, 5 joule. So this is the answer, option C. Next, a uniform force of 3 I cap plus, so this is the force, acts on a particle of mass 2 kg, mass displaced from position, so initial position, final position, work done by the force on the particle is, so work done is again given by force multiplied by, I mean dot product of force and displacement. So here we have to first we have to find the displacement. So what is displacement in this case? Again, that is change in position vector. So this here it is r2, this is r2 vector, and this is r1 vector. So r2 vector, 4i r2 minus r1, it is r2 vector minus r1 vector. So this is 4i cap minus 2i cap, that is 2i cap, 3j cap, 0j cap, so this will be 3j cap, no component j cap exists here. Here minus k cap, so this is minus 2k cap. So this is the displacement. Now we have to find the work done. So it is given by F dot S. So force vector is given as 3I cap plus j cap, 3I cap plus j cap dot delta R is this value 2I cap plus 3j cap minus 2k cap. So here work done is given by 3 into 2, 6. This will be 3 and no component of k cap exists here, so this will be 0. So W is equal to 9 joule, isn't it? So the option A is the answer. A result of A cross, listen here, two properties are being used. If you multiply any constant with vector and this vector is B, isn't it? So what is the magnitude of B? The magnitude of B is k times the magnitude of A, and the direction of B is same as the direction of B, as we have learned in this lecture. It means that if you multiply this vector with any constant, then whatever result you are getting, it is again a vector, isn't it? So if you multiply a constant 0 with any vector A, then whatever you get will be definitely a vector. So I am putting sign here like this one, isn't it? So this is a vector. The first thing is that must be vector. So you have to select that option which has arrow over it. So this option is wrong, isn't it? This option is wrong because these are two are showing only magnitude. There is magnitude, there is magnitude, but we get this value as vector, isn't it? So B vector. So out of these two we have the answer. Now the second thing is 0 is multiplied by this vector, so its magnitude, the magnitude of B is 0. So this will be nothing but 0 vector. So option is 0 vector. So this is the difference between 0 vector and 0. Second is A and B are two vectors and theta is the angle between them. A cross B is given as root 3. The value of theta is, so guys, here A cross B we have to consider only magnitude. Why? Because this you have to understand. In the question, it is not put under this modulus sign, but we have to consider only its magnitude. Why? Because right hand side has A dot B, and as we know that A dot B is a scalar. It will not have direction. So right side we have direction. So left in the right side of the expression we have only magnitude. It means that in the left side we must have only magnitude. So this will be AB sine theta. This you can solve verbally, is equal to root 3 AB cos theta. AB gets cancelled. This will be tan theta is equal to root 3. So theta is equal to 60 degree, or you can write pi by 3 radian. So this is the answer, isn't it? That A, B and C are such that A dot B is equal to 0 and A dot C is equal to 0. So this information, since A dot B is equal to 0, it means that A is perpendicular to B and A is perpendicular to C. So we have to find a vector parallel to vector A is. So the first option is A cross B. So dear students, whatever the result you are getting from A cross B, it will be perpendicular to A vector as well as B vector. isn't it? Just go through the cross product topic in this lecture. So this will not be the answer. Why? Because whatever you are getting, it will be perpendicular to A and perpendicular to B vector. B plus C. So this is a very important concept. Suppose this vector is vector B and this vector is vector C, isn't it? So whatever you are adding, if B and C, whatever the result you are getting on in this plane, isn't it? Since B and C lie in the plane of this board, so their resultant, that is B plus C, will also lie in the same plane. This is very important concept. So what happens if A is perpendicular to B and A is perpendicular to C? It means that A is perpendicular to this plane in which this B and C lie. It means that if A is perpendicular to this plane, it means that A is perpendicular to B plus C as well. So this option may not be the answer. Actually, A is perpendicular to this B and plus C, isn't it? Now let us check the third option. Now what happens? As we know, A is perpendicular to this plane. So if I wish to find B cross C, so by applying the right hand thumb rule, right hand that finger rule, so this B cross C, from B we have to move towards, we have to curl our fingers of the right hand towards C, then this stress thumb will give the direction of B cross C. So it is perpendicular to the plane of the board, that is the direction of B cross C is perpendicular to the plane of the board and into the board. So the information which is important to us is the B cross C is perpendicular to the plane of the board, and as we know that A is perpendicular to the plane of this board because A is perpendicular to B and A is perpendicular to C. So both vector A and vector B cross C both are perpendicular to plane of this board, so this may be the right answer. You have to select the appropriate one, isn't it? Next question. The angle between vector A and B is theta, then the value of the product A cross B dot A vector. Always remember, whatever you are getting from A cross B, let us suppose this is C vector. So as we all know, this C vector is perpendicular to A vector as well as perpendicular to B vector, because whatever you are getting from cross product, it is perpendicular to the plane of the plane in which the two vectors lie. That is, this C vector, if you write A cross B, C vector is equal to A cross B, then this C vector must be perpendicular to A vector as well as it is perpendicular to B vector. So if you talk about C dot A, then this will be CA cos of angle between C vector and A vector, and that is given by 90 degrees. So this will be 0. So option is 0, isn't it? Next question. A cross B is equal to, so here it is given A cross B, it means that AB sine theta is equal to root 3 and this is AB cos theta. So this AB gets cancelled, isn't it? This will be tan theta is equal to root 3. It means that theta is equal to 60 degree. So we have to find the value of A plus B resultant. So A plus B, we have the formula A square plus B square plus 2AB cos theta, and here we have cos theta, that is cos 60, and what is cos 60? That is 1 by 2, and here it is under root. So this 2 gets cancelled and we will get A square plus B square plus AB under root. So this will be the option A is the correct answer, isn't it? Just to follow the rules and you will get the same answer. You will get the right answer, I mean. Find the torque about the origin when the force of on the particle. So in the examples of the cross product, I have mentioned you about torque in this lecture. So torque is given by R cross F, isn't it? So R here is position vector, so this is 2k cap cross the force is given by 3j cap. Remember this circle, this is I cap, this is j cap and this is k cap. If you move like this, I cross j is k, j cross k is I, k cross I is j. Now if you reverse the pattern, that is k cross j, then you will get minus I, isn't it? I cross j is k, j cross k is I, But k cross j, if you put find, then it will be minus of I. So here the answer is minus of 6I cap, and this is torque, so Newton meter. Option B is the correct answer. So that's all for this lecture, dear students. Thank you. All the best.